Stop using Excel like 2015. The thing is, Excel has improved a lot in last a few years, and if you're still using old options and functions, it's high time to move to the new one. But the problem is, a lot of Excel users are still using those old functions and wasting their time in writing complex formulas. And that is why in this masterclass, we're going to learn 40 plus new and modern Excel functions. I'm going to take you to every single function in depth. We're going to learn syntax, all the arguments, and then example to learn it in depth. Hey, my name is Puneet and I'm an Excel MVP and I have been using Excel for 15 years. And in this masterclass, I'm going to take you to every single new and modern Excel function. Think about all the popular functions like XLOOKUP, filter, unique, and we are going to learn the most amazing addition in Excel, and that is all the Lambda functions so that you can create your own custom functions in Excel. Can you imagine? You can create your own custom functions in Excel without writing a single code. So make sure to download all the sample files that I have with, and make sure to follow along to every single function. And now let's start this masterclass. Before we start this masterclass, let's spend a few seconds to understand structure of a function. Now in Excel, every single function has a specific purpose. Now, whenever you want to enter a function, let's say if I want to enter this function called unique, which gives me the unique values from a list of values, I need to start with the equal sign, and that's why I have this equals here. And then I need to enter the name of the function, just like I have here. You can type this name. You can also use the autofill option that Excel gives you while typing the name. When you just type U, it'll give you the list of all the functions which starts from U. And after that, you need to specify or you need to type this starting parenthesis. And the moment you enter the starting parenthesis, you get this complete list of all the arguments that you need to specify in a function. Now, arguments are basically the values that you need to specify in a function to get the desired result. Now, in unique function that gives me the unique list of values in return, I need to specify a original list of values. And that's why in the first argument that says array, I need to specify this particular list, the list where I have duplicate values and I want to get the unique values in return. But here's one important point that you need to understand. Whenever you entering a function, you will see some of the arguments have this square bracket like I have here in this unique function. Some arguments will have this square brackets. Now, this means any argument with the square brackets means that argument is optional. Your function will still give you the result even if you skip these particular optional arguments. Whenever you entering a function in Excel, you just need to look at arguments which are required and arguments which are optional, and then you are good to go. So let's start this masterclass. So let's start with the syntax of ifs function. Now in the ifs function, you can specify multiple conditions and get a result based on if that particular condition is true or not. First of all, we have the logical test, the first logical test that you can specify. But to understand this argument, this entire syntax of ifs, let me break it down in this way. For the logical test 1, I'm using the word condition 1. And for the value if true 1, I'm saying the result 1. First of all, you can specify your first condition that you want to test and then the result you want to get if that condition is true. And then you can move to the second condition and the second result for that particular condition, the second condition, and then the third condition and result for the third condition, and then the fourth condition, result for the fourth condition, and then the fifth condition and result for the fifth condition. And this way you can specify up to 127 conditions and result for those conditions. You can test 127 conditions within a single ifs function and get results based on the result of that condition. Now to better readability, because when you writing long nested ifs function, you can use line breaks to have better readability, just like I have here. The original syntax is this, where we have logical test 1, value if true 1, but I'm using this syntax where I have simplified condition and result.
Now you can see here in this example, I have this logical test. If I have the value 1, give me A. If I have 2, then B. And if 3, then C. And if 4, then D. And here in this example, we're going to write the same ifs function. I'm going to enter ifs. And you can see I have the argument logical test 1 and value if true 1. That's the same condition 1 and the result 1. I'll move to the next line. I'll use a line break by using the keyboard shortcut Alt plus Enter to move to the next line within my function. Here I'll specify my first condition, that is cell A1. If the value in the cell A1 is 1, then give me A. My first condition is here, and the result that I want in return from the first condition, if that first condition is true, the result is there. Now I'll again use Alt plus Enter to move to the next line, and again I'll refer to the cell A1, and now this time my condition is 2 to test if the value in the cell A1 is 2 or not, and if it is, give me B. And then again line break, and condition is 3, give me C if it is true. Then again move to next line, condition is 4 to test 4 and give me D in return. Now my 4 conditions are there, and let me hit enter. It says A because the value in the cell A1 is 1. And as soon as I drag this formula down, I get a result for all the values based on the value I have in the main cell. Now let's say, because all these values that I have got in return are based on the conditions, based on the cell where the condition is met. I have 1, and that's why I have value, I have 2, 3, 4, and all these conditions I have there in the function. But what if this condition, if the value in the cell is not as per my condition? Let's say if I have 5 here, you can see in this case I'm getting not available error because I have not specified anything for 5 or anything for other than the value which is not in the condition. Now in this case, what I'm going to do, let me just copy this function from here completely and paste it here. Let me just paste it here in the new column, and let me drag this down. Now, as I said, I have nothing to test for any value other than 1, 2, 3, 4. What I'll do, I'll go to my function and let me enter a comma to move to the logical test 5. That's the condition 5. And here, for all the conditions which are not met, all the values where condition is not met, not as per the first, second, third, or fourth condition, I'm going to say true. And then I'm going to specify a value to get in return. That's, let's say, E, and close this function. And now I'm going to hit enter. When I drag this formula down, you can see now I get E for 5. And even if I change this to 6, from 5 to 6, I still get E because that's something I'm using for all the values which are not in these 4 conditions to get in return. True, and then get me E in return. Now let's understand how this line that I have added at the end of my function, true and E, this pair, how this pair works. Now what happens is I'm testing these 4 conditions here for number 1, 2, 3, and 4, and I have these results to get in return. But if my value in this cell is not from this range 1, 2, 4, what I'm saying here, to mark this already true, but only after testing these conditions. That's why I have this pair at the very end of my function, because I don't want any value to go to this line without passing through these 4 conditions. Once a value is passed through these 4 conditions, that means if I don't get A, B, C, D, that means that value is not from the range 1 to 4. In that case, mark that value true upfront, because when I test a condition, let's say if I test a condition here, either I will get true or I will get false. If I get true, I'll get value for that particular number, the condition. But if I get false, it will move to the next condition. And if I get false, it will move to the next condition. And if I get false, it will move to the next condition. And here, if I get false, that means I don't have number from this range 1 to 4. In that case, mark that number true upfront without testing anything, and then give me E in return. The position of this line, this pair true E, is really crucial. You need to add this true E, this pair true, or anything that you want to specify for other numbers, other values that you have, that needs to be at the very end of your function. Now in this example, we're going to use ifs function to create a grading system based on the score. So what I'll do, I'll enter ifs here, and I'll start with my first condition to test, and that's from the cell C2. If the value in the C2 is greater than or equals to 90, then give me an A. That's the first condition that I want to test. And after that, I'll move to the second line by using the line break, alt and enter, and I'm going to say if the value in the C2 is greater than and equals to 80, then give me B plus in result. And let me just copy this from here so that I don't need to type it again and again. And now again, the next line here, I'm going to say if the value in the C2 is 70, above 70 or equals to 70, give me B. And again, next line, next condition, if the value in the C2 is above 60, then give me a C plus. And then my next condition, this will be my last condition to test. So I'm going to say the value in the cell C2, if it is greater than 50 or equals to 50, then give me C. So here's my grading system: A, B, B plus, B, C plus, and C. Now let me close my function and hit enter. So I'm getting B plus for the score 85. And let me drag this formula down. And here I have my all the grades for the score. Now let me structure it a little bit. Let me just, and here I have my formula in a better structure. Now you know how to write multiple conditions and specify results that you want to get if that condition is true. Now, most important thing here is to understand the hierarchy of these conditions. Now here, let's think this way. What I'm saying here, if the value in the C2 is above 90, give me A. If it is above 90 or equals to 90, give me A. But my value is 85. That means this condition is false. Then I move to the second condition and say if my value in the C2 is above 80 or equals to 80, give me B plus. And that's what I was getting in the result, B plus. But if I move to next condition, this condition also tests and says if the value in the C2 is greater than or equals to 70, then give me B. But if you look at the value that we have in the cell C2, it is 85, and that's also above 70 and equals to 70. But I still getting B plus. But the point is my condition is true here and true here also and true here also, because my value is 85 is above 80, above 70 and above 60 and above 50, because I'm having true for all these 4 conditions. But I'm only getting the value for the first condition, that is above 80 or equals to 80. Now what happens is when we write multiple conditions in the ifs function, it start testing with the first condition and then the second condition, then the third condition, fourth and fifth. But if the value get true for a condition, let's say for the second condition, it will stop evaluating the next conditions that we have. If the value 85 is meeting here, the condition is met here, that is above 80 or equals to 80, it will stop moving to the next conditions. The position of your conditions are really, really important. Let me tell you something. Let me show you something. If I take the same formula that I have here and let me just paste it here. This is the same formula. I have 5 conditions which are using same numbers, same results, but the position of the conditions are totally flipped. Instead of having A first, I have C and then C plus and then B and then B plus and then A. Now, if I enter this function here and for the same value that I have in the cell C2, you can see I get C this time, because at the very first condition that says above 50 or equals to 50, my value 85 is meeting this condition, and that's why I'm getting C. That's why it's not moving to next conditions that I have in the function. So your position of the conditions within the function is very, very important. And here I have the same example and the same formula using ifs function. But if I change this value from 85 to 45, it returns the not available error. And here, when I edit my function, we again need to use that true pair that we have used at the very beginning of this video in the first example, because my range here for the condition is for 90, above 90 or equals to 92, above 50 or equals to 50. But if I have a score which is below 50, in that case, it will not test any condition, it will not get true for any condition. And that's why the ifs function will return a not available error. And that's why I need to use that pair of true and the value that I want to get if that number, that score is below 50. I'm going to say D in this case and close this with double quotation marks, close my function and hit enter. Score which is below 50, I'll get D for that. Even if it's 10, I'll get D for that. All right, so let me start off with the syntax of switch function. And the whole idea of using switch function is exactly same like we use other conditional functions like if and ifs. But how switch function works is little different from the other conditional functions. Now in the switch function, first of all, we have this argument expression. Now expression is that value or a cell reference where you have a value that you want to test. So first of all, you specify that value that you want to test throughout your function. After that, we have this argument value 1 and result 1. And these two arguments work like a pair. You specify the value that you want to test and then you specify the result that you want to get if that condition is true. So now let's say if I want to test something from the cell A1, the reference to the cell A1 will go into the expression, and then here I will specify a value that will be the condition to test. So if I want to test if in the cell A1, I have the value 1 or not. So I'll specify 1 here in the value 1, and then I'll say I want to get A in return, and A will go to the result 1 argument. I'm testing the cell A1, I'm testing it for the value 1, and I want to get A in return. So this is a very simple way of writing switch function. Now these two arguments, this pair of arguments, this way you can create total 126 conditions in a single switch function. And you need to have at least one condition and the result to complete your function. And this way you can create 126 condition, total 126 condition in a single function of switch. And the best way to write switch function is to structure your function like this. We'll learn about it in the example section, but just for your information. And once you are done with the first value and the first result, you can move to second value and the second result. And this way, as I said, you can create 126 conditions. And after that, there is one more argument that is default. So if you specify, let's say 4 conditions to test and you specify 4 values in the value 1, value 2, value 3. Let's say you specify 1 and then you specify 2, then you specify 3, and then you specify 4. So you have 4 conditions and 4 values against those conditions to get. But what if the value in the cell is other than these 4 values for which you are testing the condition? So in that case, you can specify a value here in the default to get if the value in the cell is other than these 4 values. We will also learn about this argument, this specific argument, in the example section. Now here in the first example, I have the same list of numbers here, and now I'm going to write the switch function to test multiple conditions. So I'll say switch, and to have a better structure, I'm gonna write the switch function in multiple lines. So I'm gonna press Alt and Enter, and first of all, I'm going to specify my expression, and that expression is the cell A1, the value in the cell A1. After that, first value, the condition that I want to test. So this is 1, and for 1 I want A. And then 2, the value 1, and then 2, the value 2, and the result is that I want is B, and then again 3, and then the result I want is C, and then 4, and the result I want is D. Now I have 4 conditions to test, and then I'll go to the default value to specify. I'm gonna say default value is X, and now I'm gonna close my function and hit enter. So I have A because the value is 1, and here I have B because value is 2, and then I have 3 because value is, and then I have C because value is 3, and D for 4. And when I move to the value where I have value 5, the cell where I have value 5, I get X because the value 5 is other than 1, 2, 3, 4, 5. And even if I type 6 here and drag my formula down, you can see I get X because that's the other value, and I'm using the value default here. So that's how switch function. Now there is one big difference between switch function and ifs function. In the switch function, you cannot use conditional operators. The operators that you use for logical test, you cannot use them directly in the values. Now to do that, we need to write switch function in a different way. So here I'm going to enter the switch function, and now in the expression, instead of specifying any cell C2 or anything, or even any value, I'm going to say true. And now I'm going to move to my value 1, and here I'm going to write my condition using the logical operators. So I'm going to say C2 equals to or greater than 90, then give me A. And let me just copy it from here so that I can write more conditions. And now I'm going to say if C2 is greater than or equals to 70, give me B, and if it is greater than or equals to 60, then give me C, and if it is greater than or equals to 50, then give me D. And now I'm going to specify my default value as well, and I'm going to say give me E for all the other values which are not in these 4 conditions. So I'm going to close my switch function and hit enter, and here I have B for the score 85 because the score is above 70 but below 90, and that's why I have B, grade B in return. And let me just drag this formula here, and here I have my all the grades based on the score. And just like ifs function, the sequence of conditions, the way you write conditions is very important in a switch function. So if you look at the formula that we have just right a few seconds back, we have this condition where we have above 90 equals to 90, and then above 70 equals to 70, and then for 60 and for 50. But if I write these conditions in totally opposite sequence, let's say here I have this formula, and here I have D first, where I'm saying above 50 and equals to 50, and then above 60 and equals to 60, and then for 70, and then for 90. And even for the value where I have 85, I'm getting D in return. Now the reason for this is when we write multiple conditions in a conditional function, if that condition is true for that particular cell, the function will stop evaluating the next conditions. So when I say equals to 50 and above 50, then give me D, and the value that I have here is 85, which is also true for this condition where I'm saying above 50. And that's why when this condition is true, it stops evaluating the next condition, and then the next condition, and then the next condition as well. And that's why I get D straight away without evaluating any of these conditions. So when you're writing your conditions in the switch function, the sequence of conditions is really, really important. All right, so now let's start with the syntax of let function. Now in the let function, syntax is quite simple. First, you specify a name of the variable, and then you specify the value that you want to use in that variable. And this way, so this is like a pair, the name and the value. You can see here, I have this let function here. An example I have here. Here is the name. Here is the value. Sales is the name of the variable, and 1000 is the value of the sales variable. Now, this is one pair, as I said. This way, you can specify 126 variables. Name of the variable and the value of the variable. You can specify 126 variables. Now, in the syntax, we just have a simple structure where you specify name first, just like this, and then you specify the value, just like this. And as I said, 126 variables maximum you can specify. Now, there are a few more things that you need to take care while using that function. That is, the name of the variable cannot be a name of the range. If I specify A1 as name of the variable, now in this case, let function will assume that you are referring to a cell. You're not specifying the name of the variable, but you are referring to the cell, and mistakenly, it will get that value from that cell. Let's say if I specify cell A1, instead of using it as a name, it will refer to the cell A1 and take that value, the value from the cell A1, as the name of the variable. But if you don't have a value in the cell A1, in that case, you will get an error. So you need to take care that the name needs to be a meaningful name. Now, the next thing is when you specify a name in the let function as a variable, that name is non-case sensitive. Even if you use sales like this or like this, both the values are same. And the last thing is you cannot have a space in between two words. So if you're specifying name of the variable and you have two words to use as name, in that case, you can't have a space in between, but you can use a underscore like I have here to separate two words and have more clarity while reading it. Now in this example, let me quickly show you how to use let function to create names and then perform a calculation using those names. First of all, I'll use AMT for the sales amount that I have, and here's my value in the cell C2, and then for discount, I'm going to go with dis, and here's my discount. And then for text, I'm going to go with exactly same name, and here's my text percentage. Now I have all the names, and I'm going to write my calculation. I'll say AMT, that's the sales amount, minus AMT into this, and close the calculation. Now when I hit enter, you can see I get 900. That means I'm deducting 10% discount from the sales amount here. Now, this is not the complete calculation that I want. I want to add tax after the discount. So I'll give another name to this calculation as well. So I'm going to say gross, or if I want to give a better name, I'll say after this. And now let me add my final calculation here. The final calculation is to add the tax amount and the amount after discounts. I'll say after this into, because that's 5%, it will be 105%, 105% for the final amount. I'm going to say 1. Now I'm going to add my final calculation here. I'm going to say after discount plus after discount into tax and close the bracket and hit enter. And here I have 945. That's the sales amount after discount, after deducting discount and adding tax. And now let's write one more calculation using the let function. Here I have sales amount, the same data, sales amount, discount and tax. But this time I want both the amounts. I want the amount that is after discount and with tax. That means 900 after deducting the discount and 945 after adding the tax into the amount after discounts. I want both the values, both the amounts. I'll start with the let function and I'm going to say AMT. That's the same name that I have used. Okay, so let's change it. Let's say sales. Let me use sales underscore amount. And here I have my sales amount, the first name here. And then I'm going to say discount. And here I have my discount. Everything is same. I'm just changing the names this time. And now after that, I have tax. And tax is here in the C4. And now we need to start writing our calculation. This time I'm going to say net sales. Now this net sales will be for the amount which is after deducting discount. So instead of straight away writing the calculation, I'm giving that calculation a name. Net sales is the name of the calculation, and now I'm going to write my calculation for the net sales. I'll say sales amount minus, the calculation is exactly same that we have right in the last example, but here we are using the different names. Sales amount minus sales amount into discount. And now I'll close this calculation. So the result from this calculation will go to this name, net sales. Now let me move and get my second calculation. And this time I'm also going to name the next calculation, that's the final net sales. But I'm going to say final amount. This is the name. And now I'm going to write my calculation. So I'm going to use the net sales, which is the sales amount after discount. I'm going to say net sales into, I can also use it this way, 100% plus the tax. And now I have both the calculations, both the sales amounts, and one is in the net sales name and the second is in the final amount. Now to get both the amounts, I need to use one more function that will allow me to get both the values in two different cells. I'll say extract, and here I'm going to use these two names. First of all, I need net sales, I'm going to say net sales, give me net sales, and then give me final amount. And now I'm going to close my function. Let me just explain this formula to you. First of all, I get sales amount, discount, and tax from the cells where I have the actual values. And then I get this name net sales and perform a calculation that gives me amount after deducting the discount. And that value is saved in this name, net sales. And after that, I have this name, final amount, which is calculating the sales amount where it is adding tax to the net sales, which is the amount after discount. And this amount is saved in the final amount name. And after that, I'm using HStack function to get both the amounts in two different cells. And now when I hit enter, I get after discount amount and with tax amount. So that's how you can simplify your formula. It seems like this formula is quite lengthy, but if you think about it, this formula, if you write any formula like this, specifying names and then using those names, it is way more understandable when you actually editing that formula in future somewhere, or if you want to share that formula with someone, it's really easy to understand that formula. All right, now we are into XLOOKUP function, and in this video, I'm going to explain every argument in detail and every option within that argument with an example. We are going to learn XLOOKUP in depth. So let's start with the syntax. In XLOOKUP, we have total 6 arguments, and the first 3 arguments are required and the next 3 arguments are optional. First of all, as you know, the whole idea of using XLOOKUP function is to look up for a value from an array. That's our data, the main data from where we want to look up for a value. First of all, you need to specify the value that you want to look up for. Let's say here I have this name, customer name, that I want to look up in this data. And after that, you need to specify the lookup array. Now here, the lookup array is basically that column in which you want to look up for the value. Here you have the lookup value, which is name of the customer, and now here is the lookup array. In my data, the data that I have, the column with the customer name is the lookup array, because this customer's name, I want to find it in this column or range or array. And after that, the next argument is return array. Once I find the customer's name here in this column, in this array, I need a column to get the value in return. If I find this customer's name, let's say if I find customer's name here, I want to have value from this column. That's the quantity column, and quantity column is my return array from where I want to get the value in return. Whenever you specify lookup array and return array, you always get the value in return, which is exactly at the same position in the return array. If this is the first customer's name, this is the second customer's name, and this is the third customer's name, and if I'm finding second customer's name, I will get the return value, the quantity, from the same position. That means from the second position in the column or from the array. And now let's move to our next 3 arguments. And we have if not found argument. Now let's say if you're looking for a customer's name, like I have this customer's name here, but I don't have this customer's name which I am looking for in the main data. In that case, by default, I will get a not available error. But if you look at my result here, I'm getting this custom message that says customer name is not in the list. And this custom message I have specified in the if not found argument. And that's why I'm getting this. If you don't want to have that not available error in the result. If you don't have that value in the data, you can specify that custom message in your if not found argument. After that, we have the argument match mode. In the match mode, further we have 5 options. The first option is exact match, and that's the by default option. If you don't specify anything in the match mode, you will still get the exact match. So you are looking up for this customer's name, and the match that XLOOKUP is performing is the exact match by default. After that, we have further 2 options. We have total 4 options further, but these 2 options, the second and third, they work like same. The second option says exact match or next smaller item. If you're looking for, let's say, value 4, and the value 4 is not in the list, in that case, it will go downwards and look for the value 3 or 2 if 3 is not there, or 1 if 2 is not there. It will somehow give you any value which is lower than your value, the actual value you are looking for, if your actual value is not there in the list. And the third option, that is exact match or next larger item, this works exactly opposite. So if you're looking for, let's say, 4 and 4 is not there in the list in your data, it will look for 5 or 6 or 7 depending on the availability of all these options. If 5 is not there, it will look up for 6, and if 6 is not there, it will go for 7. And after that, in the fourth option, we have this wildcard character match. You can use wildcard character match for a partial lookup value. We will understand about this option with an example. And after that, we have a regex match. In the regex match, you can use regex patterns to look up for a particular value. Now, after that, we have the last argument that says search mode. Now, in this argument, further we have 4 options. The first option is to search from first to last. That means starting from the first value and go downwards, and then search last to first. That means start from the downwards and go to the top of the data. And after that, in the end, we have 2 more options that says binary search. We will understand about binary search with an example. And if you want to learn more about binary search, make sure to watch the specific video we have about binary search in this course. Now I'm moving to my first example. Here I have customer's name and I want to get the order ID and order value. And here in this example, I'm going to show you the best thing about XLOOKUP and the reason you should move from VLOOKUP to XLOOKUP. First of all, I'll get the order value. I'm going to say XLOOKUP and select the customer name for lookup value, and the lookup array is customer column here, and I want the order value, so I'll select order value here in the return array. Let me just change it from here. You can see in the return array I have the column D, the range D2 to D6, and now I'm going to close my function and hit enter, and I get 540. That means the order value for this customer is 540. This is a simple way of using XLOOKUP function. And now the biggest problem with VLOOKUP is it cannot perform a reverse lookup. You can see here I have the customer's name and here I have the customer's column, but the order ID for the customer is at the left side of the customer's name, and that is something I cannot do with VLOOKUP. When I enter XLOOKUP and specify the customer name that I have in the cell G2 and then specify the customer column and then go to the order ID, you can see these 2 things are separate. The lookup array and the return array, we have 2 different arguments, and both the arguments and both the references are independent from each other. And that's why we can perform the reverse lookup to the left. And now I'm going to close my function, hit enter, and here I have the order ID for my customer, James Brown. And now in this example, we're going to learn about the match mode argument. When I enter XLOOKUP function here and use this value where I have the first name James, but in my data where I have customer names, I have, for all the customers, I have full names. Now, here with the first name, I have a wildcard character that is asterisk. And when I use the same lookup value and then specify the lookup array, that's the customer's name, and then go to specify, let's say, quantity. And now, because the default mode of search here in the XLOOKUP is exact match, so I need to select wildcard character match and then close my function, hit enter, and it says 3. That means the quantity for James is 3. And if I edit my function and remove this match mode here and hit enter, you can see I don't get anything. Even if I delete the if not found value and hit enter, it says not available. That means the name that I'm looking for, James, is not there. Even if I just delete this asterisk here, I'm not able to find this name in the data. When we use asterisk with a partial text, it represents anything that we have after this part of the text. Here I have James and here I have James too, but I also have the last name Brown. And when I use asterisk here, it represents everything that I have after the James, a space and the last name Brown. And to use this, as I showed you, you need to activate the match mode wildcard character match. And when I close and hit enter, I get 3, the quantity for James Brown. Now, in the same way, you can use regex match. When I enter XLOOKUP and specify the names that I have here, it says James, James Brown, and JB. That means now I can look up for 3 different versions of the name. And if I select the customer column from here and then let's say I want order value, and for not found, I'm going to say a hyphen, and then in the match mode, I'm going to go with regex match. And now when I hit enter, you can see I get the quantity for James Brown. But if I change it from James Brown to JB, I still get the quantity 540. And if I change it to James, I still get the quantity 540. That means with the regex match, I'm able to use any variation of the name that I have in the lookup value. Now let me explain it to you, the second and the third option that we have in the match mode: exact match or next smaller item, exact match or next larger item. Now when I enter XLOOKUP here and I'm looking for this value, that is 1, and my lookup array is this. This is just a small sample data that I'm using to make my point understandable. And I'm going to say return array is here where I have letters, and I'm going to hit enter to get the result. I get A in return. That's for the lookup value 1. Now if I change it to 3, I get C. Now if I edit my function back and go to exact match on next smaller item and close my function, I still get C because 3, the value 3 is there. Now if I delete the value 3 from here, you need to notice the change here. Let me just delete 3 from here. Now for the lookup value 3, I'm getting B, and B is for 2. Our match mode saying if 3 is not there, I'm going to get you value from the exact lower value, and the exact lower value from 3 is 2, and that's why I'm getting B. And if I delete 2, it will make the value 1 the exact lower value from 3, which is here, which is present here, and that's why I'm getting A in return in the result. Now let me edit my function and go to exact match or next larger item. Again, I have 3 and the result is C because 3 is there. And now if I delete 3 from here, I get D because the exact next larger item for 3 is 4, and the letter for 4 is D. And if I delete 4 from here, I get E, because now the next larger item from 3, which is present here, is 5, and the letter for 5 is E. That's how these two options work when you change them in the match mode argument. And now in this example, I'm going to show you how you can use different options that you have in the search mode. When I enter XLOOKUP here and use this lookup value, that's 1, and this is my lookup array where I have numbers, and then in the return array, I'm going to say this column where I have letters, and I'm going to close my function and hit enter. I get A because the letter for the number 1 is A. Now what is happening by default, XLOOKUP start looking for the values from the first and then goes all the way downwards. And you can see here, I have 1 here and the letter for 1 is A. But now if I go all the way down in my data, I have one more time and the letter here is U for 1. Now if I go to search mode, I have option here that says search first to last, and this is the default option which is already there. Even if you don't specify anything in the search mode, it will work in the same way, first to last. And that's why I'm getting the letter A for the 1, because that's the value at the very first in the data. But if I change the search mode from last to first and hit enter, now I get U in return, because now it is considering data from downwards, and once it finds the 1, it gives me the letter that is next to it, and then ignore all the values in the data. That's how you can change the direction of the lookup using the search mode. You have first to last and last to first. Now let me show you about the binary search that we have in XLOOKUP. With the binary search, there is no specific difference that you will see, but if you use binary search, it will make your lookup with the XLOOKUP quite faster, especially when you are working with large data sets. Now let me show you how binary search works. Now let's say if I have 5 here and I want to look up for 5 in this data, and I want to get the return array where I have letters. Now when I use XLOOKUP, enter this lookup value, select the lookup array, and then select the return array, and I get E in return. That's the letter I have for the value 5. But when I move to the search mode and I say binary search sorted ascending order, that means I want to use binary search and my data is sorted in the ascending order. Now the thing is, when you want to use binary search, your data needs to be sorted either in ascending order or in descending order, and you need to specify that my data is in ascending order or in descending order. So my data right now here is in ascending order because it's 1 and then I have 9 all the way end of the data, and I'm going to say ascending order, and now I'm going to close my function and hit enter, and again I get E because that's the letter I have in the data. Now what is the difference here? The difference is in how XLOOKUP works at the backend. So what happens is, when I activate binary search, instead of starting from the first value, that is 1 here, what XLOOKUP will do, it will go at the very middle of the data and then match this value with the middle value. If let's say if I have 6, let me just change it from 5 to 6, and my binary search mode is activated. What it will do, it will take this lookup value and go to exactly middle of the data. Because my data is sorted now starting from 1 to 9, it will go exactly in the middle of the data and match this value with this value. Now when I have 5 here and I have 6 here, that means the value 5 is lower than 6. So this is the first thing that XLOOKUP will identify. That means the value is in the middle. The value that is in the middle is lower than the lookup value. Now it can decide that either I need to travel in this direction for looking up the value, or I need to travel in this direction. Let me start with the syntax of XMATCH function. Now the whole idea of using XMATCH function is to match a value from a list of values and get the position number of that value. If I'm looking for this value in this list, the XMATCH will return the number of this value from this list. You can see this value, the name is on the 4th position, and that's why I have 4 in the result. And that's the whole idea of using XMATCH function. But in the XMATCH function, in the syntax, we have multiple ways to use the XMATCH function. So let's understand the syntax of XMATCH. So first of all, we have the lookup value. That's the value we are looking up in the list of values. And after that, we have lookup array, and that's the list of values that we are going to use to look up for the value. The first 2 arguments are required, and the next 2 arguments are optional. And the next argument, that is match mode argument. When you move to the match mode argument, you have further 5 options to use. The first option is exact match, which is by default match mode. Even if you don't specify anything, you will still get the exact match while matching the value. And after that, we have 2 more options that says exact match or next smaller item, and exact match or next larger item. We're going to learn about these 2 in the examples. And after that, we have wildcard character match and regex match. In the wildcard character match, you can use a wildcard character, and in the regex match, you can specify a regex pattern to match a value from the list. And in the search mode argument, we have further 4 options. The one is to search from first to last, which is default way of matching. And then we have the search last to first. That means starting from the last value in the list and going to the value that we have at the top. And after that, you have option to perform a binary search. And if you want to learn more in depth about binary search, make sure to watch the video that we have on binary search to make you understand how binary search works. Now in this example, I'm going to write a simple XMATCH function. Here my lookup value is 4, and when I specify the lookup array, that's the list of numbers that I have here, and close my function, I get 3 in return. That means the position of 4 in this list is 3, and that's why I have 3 in result. Now to understand the match mode, the first 3 options of the match mode, here we have an example. When I enter XMATCH and specify this price, that's $71, and here I have list of prices, and select the lookup array and then go to match mode. The first match mode is exact match, which is by default, and if I don't specify anything, just close my function, hit enter, I get not available error. That means the price $71 is not in the list of prices that we have here. And if I change it from 71 to 79, in that case I get 3. That means the position of this price is 3 in the list. Now the next option that we have is the exact match or next smaller item. Now let me add the XMATCH function again, and here's my lookup value, and here's my lookup list, the array that I have, and then I'm going to go with exact match or next smaller item. Now what happens is when I use this match mode and I don't have the price 79 in this list, let's say if I delete it, you can see for the exact match I get not available error. But for the exact match or next smaller item, I get 2 in result. Now what happens is when 79 is not in the list, what it will do, what XMATCH function will do, it will go to the value which is exactly smaller than the $79. And here in my list, the value 69 is exactly smaller than the value 79. And that's why I'm getting 2 here, because the position of 69 in the list is 2. And if I delete 69, it gives me 1. Now after 79, in this list, the next smaller item is 59, and that's why I'm getting the position number of 59, which is 1 here in the result. And the same thing goes with the exact match and larger item. That means either exact match if that value is there in the list, and if that value is not there in the list, then the exact larger item. If I use the same XMATCH function and change the option from here, that's 1, and hit enter, it says 3. That means the position number of 79 is 3. But now if I delete 79 from the list, I get 4. The 4 is because the exact next larger item from 79 is 89, and the position number of 89 is 4 in this list. That's how these two options, exact match or next smaller item, exact match or next larger item, work. Now here I'm going to use an asterisk wildcard character with my lookup value. When I enter XMATCH, and here's my lookup value, and I'm going to say the product code column, and from the match mode I'm going to select wildcard character, close my function, hit enter, and it says 3, which is the position number of the product code where I have lap-1004, and as I have the asterisk along with my lookup value, and it represents any value after 1004. It matches this part of the value, and after that, even if I have a number or letters, anything, this asterisk represents that part of the value. And that's how I can perform a partial match using the asterisk wildcard character. And now in this example, this regex pattern says a value that has XYZ hyphen and then 4 numbers, and then again a hyphen, and in the end either Y or X. And you can see I have 2 values here. The one is this one where I have XYZ hyphen 4 numbers hyphen and Y, and then again XYZ hyphen 4 numbers hyphen and then X. And now when I say XMATCH, use this lookup value, this regex pattern as a lookup value, and go to my product code column. I'm going to say regex match, close my function, hit enter, and it says 2 because the position of this value where I have XYZ 4 numbers and Y is 2. And when I delete this value from here, now it says 5 because now the position number of the next value where I have XYZ 4 numbers and then X is 5, and that's why I have 5 in the result. Alright, so let me start off with the syntax of TEXTJOIN function. The whole idea of TEXTJOIN is to join values from multiple cells into a single cell. So first of all, we have the argument delimiter. So delimiter is basically that symbol, the text, anything that you want to have in between two values. So let's say in my example, I have this comma and space between these two values. I have first name here and the last name here, and I'm using this comma as a delimiter. And in that case, I need to specify comma here in the delimiter argument. After that, we have the argument that says ignore empty. Now here you can see some of the cells that I have in my data are empty. And if I don't specify, so when you move to ignore empty argument, you will get 2 options, true or false. So false is to not to ignore the empty cells, and if you don't ignore the empty cells, you will get the result something like this, where you have this comma but you don't have any value before and after this. And the same thing goes with this value, where you don't have the first value but you have the second value, and it's showing, and it shows this comma before the second value. So to deal with this problem, you can use ignore empty argument and specify, hey, I want to ignore the empty cells. And after that, we have the text, the actual text that you want to use to combine. So we have text 1, but if you have multiple text, let's say I have text 1 here and then this text, I can specify the second text after the text 1. And here I have the same data, and let me enter the TEXTJOIN function, enter my delimiter, that's comma and a space, and ignore empty cells. And in the text, I'm going to say cell A2 and B2, close the text join and hit enter. And values are now joined in a single cell. And because I'm using the ignore empty argument, I'm saying ignore the empty cells, and that's why I don't have a comma for values where I don't have the first or the last value. And here again I have multiple values in a single row, and I want to use text join to join these values. I'm going to say a space this time, ignore empty cells, and here's the reference where I have the values to join, and hit enter. And here are all the values that I have. And in this example, instead of having values in a row, I have a column of values, and I can use text join function in the same way. So when I enter text join, specify my delimiter, let's say again, comma and space, ignore empty cells, and then the range where I have the names, and hit enter. I get all the names in a single cell. Now in this example, I have name of the student and date of birth, and I want to join both the values in a single cell. So when I use text join and specify the delimiter, let's say this time a hyphen, a space, hyphen, and again a space, and then I'm going to say ignore empty cells, and here I have my text. Now in this example, when I hit enter, you can see I get the name, I get the delimiter, but I don't get the format of the date correct. So this is one of those situations where I need to specify the value, the first value and the second value in two different arguments. So first of all, I'll specify the name in the text 1, and in the text 2, while specifying the date of birth, I'm going to use a function, and that function is text. And in the text, I'm going to specify the cell where I have the date, and along with that, I'm going to specify a format, the date format that I want to use. So I'll go with the same format, D, M, and then again Y, close the format, close the text function, close the text join, and hit enter. And now you can see I have my values joined in a single cell and along with the date format. Let's start with the syntax of text after and text before functions. We have total 6 arguments to define, and the first 2 arguments are required and the next 4 arguments are optional. And this is same with both the functions text after and text before. Now the text argument, the first argument is the original text value from which you want to extract your substring or a part of the text. And after that, we have the second argument, that is delimiter. Delimiter is that character that you want to use to extract the text. You can see here I have this value here, and in this value I have these ampersand in between each word, and I can use ampersand as a delimiter to extract the part of the text from the cell A1. So I'll specify ampersand in the delimiter, or if I want to go with the second value where I have underscore, I'll specify underscore in the delimiter argument. So these two are the required argument. You need to specify at least a text and then a delimiter to extract the part of the text or the substring. And after that, we have next argument, that is instance number. Now, if you look at this value or all the values that I have in this example, I have multiple delimiters. So I have more than one ampersand, and here I have multiple underscores, and the same thing is with this value. Now, let's say if I want to extract text after this ampersand or text before this ampersand, I need to specify the instance number of this ampersand. So this is the first one, this is the second one, and this is the third one. So if I want to get value after this ampersand or before this ampersand, I need to specify 2 in the instance number. And the same thing goes with the text before. If I want to extract the text before the second ampersand, I need to specify 2 here. And if I want to extract text before the third ampersand or after the third ampersand, I need to specify 3 here. So that's how the instance num argument works. And there's one more thing to it. Let's say if you want to start your text extraction from the right side, the end of the text, in that case, these instance numbers will be -1, -2, and -3. And if you want to start from this side to this side, then it will be 1, 2, and 3. So that's how you can choose the direction of the extraction using the instance num argument. So we'll understand about it in the examples section. But now let me move to the next argument. Now the next is match mode argument. Now in the match mode argument, you can specify that if you want to perform a case sensitive match or case insensitive match. So if you look at this third value that I have here, you can see I have X in between the words. And here the X is in the capital and here it's in the small. Now if I try to use X as delimiter, both the functions will differentiate this X from this X. In this case, when you're trying to specify instance number, the instance number 2 will not be this, but this for capital X. And if you want to change it to case insensitive, you just need to change it from the match mode argument. We will also understand about this argument more in the example section. And here, the next argument is the match mode. Now, the match mode argument has a very specific use that I'm going to explain it in the example section. And in the end, we have this if not found. If somehow you specify a delimiter and that delimiter is not there in the original text and you don't get anything in return, instead of having an error, you can use if not found argument. You can specify a meaningful message or any value that you will get if you get error in return from both the functions. So now quickly let's jump into the example section to understand each argument with an example. Here I have the same value and I'm gonna enter text after function, and in the first argument I'm gonna specify the text, and after that I'm gonna specify my delimiter, that's a hyphen, and close the function without moving to any other argument. And now as soon as I enter my function, you can see I'm using text after. That means I want to extract the text after the hyphen. And when I hit enter, I get the part of the text that I have after the first hyphen. And if I enter text before and then specify this text, enter the delimiter hyphen, close my function, hit enter, this time I get text before the first hyphen. That's the simple way of using text after and text before functions. By default, when you don't specify anything, it will extract the text after or before the first instance of the delimiter. So that's how these two functions work by default. Now in this example, we're going to learn about the instance number and how by using instance number, we can decide the direction of the extraction. So I'm going to enter text after, specify my text here, and the delimiter is again the hyphen. And now I am going to move to the instance number argument. Now here I'm going to say 2, the second instance of the hyphen. And now I'm going to close my function and hit enter. And now my after text starts from the second hyphen, the hyphen that I have here. And that's why I have Excel champs in the result. And the same thing goes with the text before. Here's my text, the delimiter hyphen, And when I say 2, the instance number 2, it gives me the text before the second hyphen. Now let's say if I want to start from this side, when I'm using text after, I want to start from right side. So I will say -3 and I will hit enter. And now I get the text after this hyphen. But if I start from here, this hyphen is the first one. But if I start from here, this is the first, this is the second, and this is the third. And that's why I have text after the third instance of the hyphen. And the same thing here, if I want to have text before the -1, not -3, -1, and when I hit enter, you can see I get this part of the text. Because when I'm starting from here, the first instance is this, and I'm getting the part of the text before this hyphen actually, because I'm using text before function. So this is how you can use the instance number to decide the direction of the extraction. Now let me show you one more example to understand the case insensitivity in both the functions. So when I say text after, and here I specify the cell A1, and I'm going to say my delimiter is X, and I skip the instance num argument. And in the match mode, if I don't specify anything, just close my function and hit enter, you see I get not available error because I'm specifying X here, but this X is in small letters. And when I drag this formula down, I get the text for these two cells, because in this case, in the cell second and third, I have X in the small letters, but for first and second, I have in capital letters. Now to deal with this problem, I'm going to move to the match mode. Let me enter comma again. And now I'm going to say case insensitive match. And now when I hit enter, you can see I get text after the X that I have in between. And the same thing goes with text before X. Case insensitive match. Close the function and hit enter, and here I have text, the value actual, which is a number before the X from the original text. And now in this example, we're going to understand and we're going to use the match and argument. So when I enter the text before function and specify the cell A2 and then specify my delimiter, that's hyphen, and close this function and hit enter and drag my formula down, you can see I get the not available error for the cells where I have only the first name and I don't have the delimiter there. Now when I go back and edit my function, move to match and argument, here I have two options. Now when I go to match to end and close the function and hit enter, this time I get first name for all the other cells where I have the delimiter, but in the cells where I don't have the delimiter, I still get the first name, the text actually which is before the hyphen. Now again, let me explain it to you. In that case, the text before function also consider that at the end of the value, we also have the delimiter, and here the delimiter is hyphen, and it will consider that we also have a delimiter at the end of the value. And if I have a delimiter at the end of every value, so this is just assumption of the function. It's not there, the actual delimiter, the actual hyphen is not there, but this is a kind of assumption that get activated when we choose match to end argument. And when there is a hyphen at the end of each value, and when I'm saying I want text before the hyphen, so what is happening here for this value, because the first instance is here, I get this value, and then for this value I get this value because the first hyphen is here, But for the values where I don't have hyphen, but the text before function is assuming that I have a hyphen at the end of the value, in that case, I get this part of the value instead of an error. And that's the whole idea of using match to end argument. It creates an assumption of having the delimiter also at the end of the value. And now in this example, you can see we have different names, and all the names have different character in between the first and the last name. Now, if you want to use text after or text before function and you want to specify multiple delimiters, in that case, you need to specify these characters in this way. You need to have curly brackets, and then using the double quotation marks, you need to specify your one delimiter and then a comma and then again double quotation marks and in between your second delimiter. And this way you can have multiple delimiters which are wrapped within curly brackets. And now when I hit enter, you can see I get text after for each of the delimiters that I have here. And the same thing goes with the text before. Here's my value, the main text, and here I'm going to say all the delimiters that I want to specify, and when I hit enter, I get the first name here. So that's how you can specify multiple delimiters in a single function, single text after or text before function. All right, so let me start off with the syntax of text split function. Text split function has a lot of different options in the syntax that you can use to design the formula that you want to use to split the text. First of all, we have the text, the original text that you want to split in two parts. After that, further two arguments, column delimiter and row delimiter. Both the arguments require same thing, but it is a choice that you can make if you want to split your data in horizontal way or in vertical way. Let's say I have this value here where I have name of fruits in a single cell and I have this hyphen in between the names. Now when I split this value in three different cells, apple in one cell, banana in one cell and mango in one cell, how I want to split these names. I want to have these names three different cells in a single row. That means three different columns. In that case, the delimiter, the hyphen here, I need to specify in the column delimiter. But if I want to split these names in a single column but multiple rows like this, then in that case, I need to specify the hyphen in the row delimiter. That's how you can choose how you want to split your original value in multiple cells. After that, we have this argument ignore empty. Now, in some of the cases, when you have more than one values to split, some of the cells have blank values. In that case, you can specify here if you want to ignore those empty values or empty cells. We will learn about this argument in the examples section. After that, we have this argument that says match mode. Sometimes instead of a hyphen or underscore or space, we have an actual alphabet that we want to use as a delimiter, that we want to use to split our value, the original value, in multiple values. And if that delimiter is alphabet, in that case, if you want to use the case insensitivity match, the match mode, you want to have the case insensitive match mode or case sensitive match mode. So we use an example to understand this argument as well. And in the end, we have paired with argument. Now the paired with argument is specifically designed for situations where you are splitting text into two-dimensional array, a kind of a table, using both column delimiter and row delimiter. We will understand about paired with argument with an example. Now in the first example, I have this list of fruits where I have multiple names in a single cell and I want to split them into from one cell to multiple cells. I'm going to enter text split, select the text, and then I'm going to say column delimiter is a space and then hyphen and then again a space. And just by ignoring all the other arguments, I'm going to hit enter. And here you can see I get apple, banana, and mango in 3 different cells. And let me just drag this formula down. And here I have names for all the original cells. I have multiple splitted names here in multiple cells. And now in this example, I'm going to use column delimiter and row delimiter both to split this value, not in multiple cells, but as a table. What I'll do, I'll enter text split and then specify this value here. And then for column delimiter, because I have 2 delimiters here, the one is this equals sign and the second is this comma. I'm going to say first split the values using the equal sign. I'm going to say equals and close my delimiter and then move to the row delimiter. It will split apple and the value, the count 5, in 2 different columns because I'm using column delimiter here for equals. Now to split further this value into different rows, I'm going to use row delimiter and I'm going to say a comma and a space, and then I'm going to close my function. Now I have equal sign and this comma and space, and when I hit enter, you can see it gives me this small table where I have apple and count of apple, mango and then count of mango, and then peach and then the count. And now in this example, I'm going to show you how you can use ignore empty argument. When I enter text split, specify my value and then the column delimiter, and that's a comma. And when I close the function and hit enter, you can see I get the values splitted in multiple cells, but I also have one blank cell here because I have 2 delimiters here, 2 times comma, and this makes function to see there is a blank value within these 2 commas. But I'm going to use the ignore empty argument here. I'll say ignore empty cells, and now when I hit enter, I get both the names, both the fruit names in 2 cells without any blank cell. Now here in this example, I'm going to show you what's the importance of match mode argument. Now when I enter text split and specify my cell here where I have this sizes, where I have this size, and let me specify my delimiter, that's a space, and then again a space. And now when I close my function and hit enter, you can see for the first value where I have x, the small x value is splitted in 2 cells, but not for the second value, and then again for the second value and not for the fourth value, because text split is working as a case sensitive function here. To move from case sensitivity to case insensitivity, I need to go to the match mode argument and say case insensitive match. And now when I hit enter, this time I have my values in 2 different columns. And now in this example, we're going to use the pad with argument. This is the same value we have used to split single value from a cell into a table where we have used column delimiter and the row delimiter. Now when I enter text split this time and specify the value, the original value I have, and then row delimiter is again equals, and then now when I enter text split this time and specify the value and then column delimiter, that's equal sign, and the row delimiter is a comma and a space. And now when I hit enter, you can see I get my value in as a table, but now I'm getting this not available error. The reason is that I don't have a count for the mango and I don't have equals sign here, so that text split function can identify that I have a value after equal sign. That's the problem here in this value. To deal with this problem, I'm going to go with the pad with argument and I'm going to specify a value here. Let's say a simple hyphen. And when I hit enter now, instead of not available error, I have this hyphen that I have specified in the pad with argument. Now let me show you a kind of a limitation that text split function has. Now when I enter text split here and simply specify my delimiter, let's say column delimiter, hit enter, I get all the three parts of the main value into 3 different cells. But what if I specify an entire range? Let's say A2 to A10, because that's the range for which I want to split my text. And if I'm specifying this entire range instead of a single cell, A2, and when I hit, with this approach, I'm not able to get all the values from the main, from the main data. I only get first value, the first part of the value from each of the cell that I have. So this is kind of a limitation that we have with the text split function, and we call it array of arrays. And to understand what is array of arrays, you need to watch the video that we have in this course specifically on this topic. Let me start off with the syntax of array to text function. Now in the array to text function, we have 2 arguments to define array and format. In the array argument, you need to specify to the list of values that you have in a range. And in the format argument, you have 2 options to choose from that you want to use while converting this array into a text. When you move to the format argument, you can enter 0 or 1. When you enter 0, which is by default is there, if you don't specify anything in the format argument, it will still use the same value. When you specify 0, or if you don't specify anything, you get a format like this, where you have one value and then a comma and then space and then the second value. But when you specify 1, which is for the strict format, you will get your final result something like this, where you have 2 curly brackets starting and at the ending, and in between you have values which are divided with a semicolon. So you have these 2 options to choose from. Now, if I go to my first example, I have the same values here, and when I enter array to text function and specify this array here, and now you can see I have 2 options to choose from in the format argument, that's concise and strict. When I go with concise and close my function and hit enter, I get these values here 1, 2, 3, 4 with a comma and a space in between. And when I enter array to text function again, select my array and go with the strict format and close my function. Now this time I have the same curly brackets and then a semicolon in between the values. Now here in this example, let's say you want to use the array to text function to convert your entire table into a single cell. In that case, we'll again use the array to text function, select the entire table in the array, and the format I'm going to go with strict this time. Now when I close my function and hit enter, you see I get all the values in a single cell. But there is one thing that you need to understand. You need to note down that here we have the first row of the data, that's from name to region, and we have double quotation marks for each value, and then in between we have this comma. But as soon as you can see here, as soon as the first row finishes and the second row starts, we have this semicolon in between. So that is the sign you can use to identify that from here the first row is finished and the second row is getting started. The whole idea of using array to text function is to combine it with other functions to manipulate your text values. Let me start off with the syntax of detect language function. Now this function is quite simple and syntax is also quite simple. You just need to specify the text for which you want to detect the language. When you do that, when you insert this function and specify that text, you get this code in return that is the sign of which language is that text in. If I'm specifying the English language, I'll get EN in return, and if I'm specifying Spanish, I'll get ES in return. And in the same way, if I specify Hindi, I'll get HI in return. That's the whole idea. You specify the text and you get the code. Now, there is a documentation page that I would recommend you to just go through, because all the languages which are supported by this function is there on this page. And there's one really important thing, that this function is service-based function. to identify that language, it has to use a kind of algorithm, or you can say a service, and that service is connected with the internet, and that's why you need to have a working internet connection to use this function. A small example here, I have got this table from the same page, from the same documentation page, where I have the name of the language and then I have the code for the language. When I use detect language function and specify my text, I get the code in return, as you can see. Now, to actually get the name of the language, I can use this table that I had got from the documentation page. What I'll do, I'll enter XLOOKUP function, and the code that I get from detect language is my lookup value. I'll go to the lookup array. That's the lookup code column. That's my lookup array. I'm going to specify this lookup array and then the return array. That's the language's name, the name of the language. And I'm going to come back, and if not found, blank, exact match, close my function and hit enter. And here I have the actual name of the language: English, Spanish, and Hindi. That's a simple way of detecting language using detect language function. All right, so now let me start off with the syntax of translate function. In the translate function, we have total 3 arguments to define: text, which is the original text that you want to translate, and after that we have the source language, that's the language of the original text, and then the target language, the language in which you want to translate your text. Now, when you specify a cell or you specify the text that you want to translate, you move to the source language argument, and here you get a list of languages that are supported by the translate function, and then you need to select the source language, and then you move to the target language argument. You again get this list and select the language in which you want to translate your text. So this is the simple way of using translate function. The point is, translate function uses service that translate your text from one language to another language, and for this you need to have a working internet connection so that it can translate your text in the real time. And if you don't have the working internet connection at the time you are using translate function, you will get the connect error in the result. And as I said, you need to specify the source language. Here, when you get this list, you specify a code of the source language and the target language, and if that code is not valid, in that case you will get a value error. Now, as you can see in the syntax, both of these arguments are optional. So if you don't specify the source language, the code for the source language, translate function will automatically detect the language that you have right now. So if my language is English, it will detect it, and if my language is, let's say, Hindi, or even Chinese or Spanish, it will detect that language automatically. And if you don't specify the target language, in that case it will translate your text into the default language that you have in your system. So let's say if I'm using English as my default language in my system, in my computer, in that case my text will be translated into English. And here we have a documentation page from Microsoft that I would recommend you to just go through. Here we have a list of all the languages which are supported by the translate function. Now in this example, I have this short text in Hindi and I am going to translate it into English. And let me enter the function. And once I specify the text, now I'm not going to specify anything, neither the source language nor the target language. I'm just going to close my function and hit enter. And you can see I get my text translated into English because my default language in my system is English. And it was able to detect that the text that I have specified is in Hindi language. Now here I have this data of reviews, customer reviews, and I'm going to use the translate function to translate all these reviews in English. So I'm going to select the text, the cell where I have the text, and in the source language, you can see when I move to source language argument, I get this list where I have all the supported languages. And now I have multiple languages in the original review. That's why I'm going to skip the source language, and in the target language, I'm going to say EN. That means EN is basically the code for English, and I'm going to say English EN with this code and close my translate function. And let me drag this formula down. And here I have my text, my review text translated into the English language. And now in this example, I have a single text in English and I want to translate it into multiple languages, multiple other languages. So I already have the codes for the language. And now I'm going to say translate and specify the text, the original text that I have, and my supported language is English. And even I can skip specifying the source language, but let me move to the target language. And here, instead of specifying a single target language, I'm going to select this entire range where I have the codes. I'm going to close my function and hit enter. So you can see I have got all the translated text in an array for all the languages. And here let me show you something that makes this translate function quite smart. You can see here in the first result, I have my text translated into Hindi and all the words are in Hindi, but this word is in English. And the same thing goes with the Korean. The word translate is in English, and then again for Vietnamese, this is Excel, and the same thing with other languages as well. Translate function understands the context of the translation. It's not just it will translate your text from one language to another language, but it will also understand the context, the meaning of the translation. Because let's say in Hindi, I will use the word Excel even if I'm speaking in Hindi. So here the Excel is the spreadsheet program that I am referring to. I'm not referring to something else which is Excel or have different meaning, but I'm specifying, but I'm using Excel, which is a spreadsheet program. And that's how it understands the context of the text and then translate it into different language. Now let me come back to my second example and show you one thing which is quite smart while using the translate function. Now in the translate function, when you go to source language argument or target language argument, you have this list of languages from where you can select your language. Now the point is, let's say if I want to say my source language is Hindi, and if I try to type HI, I'm not able to get it by typing HI. Now if I want to search within this list, what I need to do is I need to enter double quotation marks first and then type HI. You can see now it gives me the language Hindi, and the same thing goes with English. If I say EN, it gives me the language code for English. So instead of just typing straight away, you can enter double quotation marks and then start typing the name of the language that you want to use for source language or target language. Let me start off with the syntax of sort function. Now in the sort function, we have 4 arguments to define, and the first argument is required, that is the array argument. And the next 3 arguments that we have, sort index, sort order, and BYCOL, these 3 arguments are optional. Now in the array argument, that's the first argument, as I said, which is a required argument. You need to specify the data that you want to sort. So in my case, I have this data here in the column A, B, C. In the A column, I have names. In the B, I have age. And in the C, I have score. Now, when I specify array, this data here in the array argument, after that in the sort index, I need to specify which column I want to use to sort my data. So let's say if I want to use the name column, which is the first column, so I'll specify sort index 1. That means the first column. And if I want to go with the age for sorting, I'm going to say 2. And for score, I'm going to say 3. So this is how you specify the column number to sort your data. After that, we have sort order. Now sort order says if you want to sort your data in the ascending order or in the descending order. So when you move to the sort order argument, you have this option to choose which order you want to use. Now, after that, in the end, the 4th argument that we have is BYCOL. Now, BYCOL argument is basically to choose if you want to use columns to sort, or if you want to use rows to sort. Normally what happens is when we have data like this, the data that I have here, we use by rows because we want to sort rows, not the columns. We want to sort data in this direction. That means we want to sort the rows. And if somehow we want to sort our data in this direction, in that case, we're going to go with columns. So we'll understand about this argument and all the arguments in our examples. Now here I have the same data in my example and I'm going to enter sort function. And when I enter sort function, I get the first argument, that is array. So I'm going to select my data here and then I'm going to press Control Shift and equals to come back to my current cell. And after that, I'll move to sort index. And as I said, in the sort index, I need to specify the index number of the column or the row if I'm using a different sorting direction. In that case, I need to specify the row number. But now see it as the column number. So I'm gonna use the age, the column age, where I have age for sorting. So I'm gonna say 2, that's the second column. And in the sorting order, I'm gonna go with ascending. That means from lower to higher. And now when I move to BYCOL, as I said, we have this option, sort by column or sort by row. And I'm gonna go with sort by row. Now you can see here the last 3 arguments, sort index, sort order, and BYCOL, these are the optional arguments. Even if you don't specify these arguments, there are some default values that the function will use and sort your data. So let me just show you this one first. When I have the second column for age for sorting, and then 1, that means in the ascending order, and false by sorting by row. So you can see we have our data sorted starting from the age 20 to all the way 30. And let's say if I delete all the last 3 arguments and just specify the array. And now when I hit enter, in this case, what is happening? The sort function is using the first column as my sorting column. So for sorting index, it is using the first column. That means the name column. And for the sort order, it is using from A to Z. That means the ascending order, if we have numbers here, so it will use the ascending order. So here, because we have names, which is a text column, the data is in text, so it's using A to Z. And BYCOL argument, in the BYCOL argument, it is using by row. So these are the default values that sort function will use if you don't specify anything in the last 3 arguments. And now let me enter sort function again and the same array that I have. And then in the sort index, I'm going to say 3. That means the score column. And by descending this time, and again, I'm going to go with sort by row. Hit enter, and this time I have data sorted from the highest score to the lowest score. Now here I have a different kind of data where I have scores, but my data is in the horizontal way. So I have columns for each student. Instead of having data in the vertical way, I have data in the horizontal way. So now I'm going to sort data based on columns. So here I'm going to enter sort function, and this is my array. So I'm not going to include the headings column, and I'm going to say sort index, because this time I want to sort data by columns. So index means which row I want to use for sorting. So I'm going to say the last grade row I want to use for sorting. So I'll go with 4th. That means the 4th row. Now sorting order will be ascending. This will be grade A to grade D. And now here, this is the setting, this is the argument where you need to make the change because our data is in different form. So this time I'm going to go with sort by column. Sort by column. And now I'm going to close my function and hit enter. And here you can see I have data, I have name, I have age, and then score, but my data is sorted using the grade row. So you just need to make the change in the BYCOL argument if you want to sort data based on columns or based on rows. Now let's say in this example, if I want to flip my data, I don't want to sort, I want to sort this data, but I want to flip this data so that I can have all the names from the end of the this data table at the front and names from the front at the very end. So what I'll do, I'll enter a custom row here. I'll enter 10 here, and then I'm gonna say -1, and I'll go and drag this formula to the right side. Now I have a row that starts from 10 to 1. And now I'm gonna go to my blank cell and I'm gonna say sort and select this entire data. And the sorting index will be 1 with my custom row, and sort order is ascending, and sort by column again. And now when I hit enter, my data is totally flipped. All right, so now let's start with the syntax of sort by function. Now in the sort by function, we have first 2 arguments required. That's array and by array. And after that, we have one more argument, that is sort order 1. First of all, in the array, we specify the data or array or a range that we want to sort. In my case, I want to sort this range where I have numbers 1 to 4. And I want to use this range for sorting. And this will go to my by array argument. And after that, we have one more argument, that is sort order, which is an optional argument. You can skip specifying it. And with this argument, you can specify if you want to sort your data in the ascending order or in the descending order. And if you don't specify anything, as I said, this is an optional argument. It will by default sort data in the ascending order. And these 2 arguments work like a pair. You specify a column and then you specify the sorting order for that column. This is the main data that's you specify only once, the original data that you want to sort, and then you specify a column that you want to use to sort the original data, and then the sorting order. These 2 arguments, as I said, work like a pair. Now, this way, you can specify one more pair where you specify a column and then sorting order. And this way, you can total specify 126 sorting orders, 126 pairs of sorting column and sorting orders within a single function. Now let me show you a simple example to use sort by function. When I enter sort by function, and again, and here I have the array, the first argument, that's my original data, and then by array 1, that means the column that I want to sort my data, that I want to use to sort my data. I'll go with country, and then I'm going to choose the order, ascending order or descending order. I'm going to go with descending and close my function here and hit enter. And you can see my data is sorted based on country column using descending order. And in this example, let me show you how to sort data using 2 different columns. I'll enter sort by function and select my main array, the original data, and then I'm going to go with country and -1 for descending order, and then again the next column, that's sales, and 1 for ascending order. And now I'm going to close my function and hit enter, and here you can see I get my data sorted first based on the country column in the descending order, that's starting from USA to all the way Australia, and after that the sales amount in the ascending order starting from the lowest to highest. Now here I have a custom sorting order to use in sorting my data. I have this custom sorting order where I have UK, and then I have India, and then USA, and then Australia. This is the sorting order that I want to use to sort my data. What I'll do, I'll use the sort by function and select the array, the original data, and in the by array, instead of specifying this sorting order straight away, I'm going to use a function, and that function is XMATCH. And in the XMATCH and the lookup value, I'm going to specify the country column from the original data, and in the lookup array, I'm going to specify this list of sorting order where I have name of the countries that I want to use to sort the index as a sorting order. And I'm going to close my match function, and now let me close my sort by function and hit enter. And now you can see my sorting order is, first I have UK, and then India, and then USA, and in the end I have Australia. That's the exact sorting order that I have here. Now, if I change this sorting order, let's say if I add USA here, and then I add India, you can say it's changing as per the sorting order that I have in this list. Let me just type. So that's the way to sort your data using a custom sorting order. So let me start with the syntax of filter function. Now in the filter function, we have really easy to understand syntax. We have 3 arguments to define, and first 2 arguments are required and the last one is optional. Now, first of all, we have this array argument, and after that we have include argument. Now in the array argument, you need to specify the data or the array that you want to filter. Array is the original, the main data that you want to use to filter the data from it. That's the array. And after that we have include argument. Now let's say if I want to filter data only for the laptop, the product laptop, in that case, what I'll do in the include argument, I'm going to specify this entire or column where I have the products, and along with that I'm going to specify using equal sign the word laptop. That's what I'm going to do in the include argument, so that I can specify, hey, I want to filter my data based on this column and based on this value. And after that, in the if empty, you can specify a value to get if there is no data for the condition for the value you are looking for. Let's say if I'm looking for laptop, I get data for the laptop. You can see here, I have this small table where I have 2 entries here. But what if I'm looking for a product which is not there in this data? I will get this calculation error. And not to get this calculation error or to get a meaningful message if the data is not there, in that case, what I can do is I can specify a value like this in the if empty argument. And when the data is not there, I will get that value or that message, that meaningful message, instead of the calculation error. That's how you can use the if empty argument, which is an optional argument, but you can specify a value to get when data is not there. Now in this example, here I have data for students where I have name, age, subject, and school. Now here my idea is to filter data based on the age, and I want data for all students whose age is greater than 20 or equals to 20. What I'll do, I'll enter the filter function here and then go to my first argument, that is array, and I'm going to select the data that I have here starting from the first name, excluding the heading row. And I'm going to press Control Shift equals to come back to the cell, the current cell where I'm entering my function. And then in the include argument, I'm going to select the age column, and again Control Shift equals. And now before I move to next argument, I need to specify my condition as well. I have specified my age column, and now I'm going to say greater than and equals to the value that I have in the cell G1. That's the age that I'm going to use to filter the data. Now I'm going to go to if empty, and I'm going to say no data found if there is no data that I'm looking for. And I'm going to close my function and hit enter. And here you can see I get data for all the students with the age equals to 20 or above 20. Let me just apply this filter manually and show you. And if I change, let's say if I change this age value from here, from the cell G1, if I enter 25, I only get data for the age 25. That's how you can filter data using the filter function. But now let me show you how filter function works at the backend. When I edit my function, you can see here I have this range where I have the entire data. And when I press F9, you can see I have this data here, entire data for all the rows starting from the first row to last row, where I almost have around 500 rows in this data, and I have this entire data as an array here in the array argument. Now, if I go to include argument and try to show you, let me just press F9. Here I have this array where I have values false and true. Now why this false and true? Let me just go here and show you. You can see I have these values false, 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 and in the fifth value I have a true. And why is that? Here's my condition, that's 25, and if I go to my data, let me just show you. This is the first value, second value, third value, fourth value, fifth value, and my condition here is 25, and the age here is 25 in the fifth row. And that is why, by ignoring all the rows, first four rows, I have true at the 5, because here my condition is met. The age that I'm looking for, 25, is there in this row, and that's why I have true here. When I get true in this include argument for all the rows where the age is 25, that's how filter function use this array and filter data from the main data that I have specified in the array argument. And if you change the condition from here, let's say if I go from 25 to, let's say, 24, now my condition is changed and I have data for age 24 as well. And when I edit my function and go to include argument and then press F9, this time you can see, let me just go at the very starting. Okay, now here I have false, false, and then I have true for the third value. Now if I go back to my data, this is the true here. Let me mark it from here. And then when I go to the third row, you can see here, I have the age 24 here. That's why I have true in my include argument, the array that I have in the include argument. And that's how the filter function will filter data from the original data in the array argument. Now here I have the same data, and this time instead of using the age, I'm gonna go with the name. What I'll do, I'll enter filter function here and then go to my data and then again select the name column, because that's where I'm going to specify my condition. And the condition is to test for the name that I have in the cell G1. And again, for if empty, I'm going to say no data found. And my function is ready. Let me hit enter and see what I'm going to get in return. And I have data for Stacy Yang. But as soon as, let's say if I take a different name here, let's say if I go with Ryan and paste Ryan's name here, and I get data for Ryan. That's the simple way of using filter function. But in the formula section, we are going to learn a lot for filter function and how to use filter function with other functions to filter data. So let me start off with the syntax of unique function. Now in the unique function, we have three arguments to define, and the first argument is required, that's array. And after that, we have two more arguments which are optional. Now in the array argument is basically the data that I want to use to get unique values from. And after that, I have the BYCOL argument, which allows me to specify if I want to have unique rows or unique columns. We will understand about this argument when we move to our examples section. And after that, we have the third argument, which is also optional, that allows us to specify if we want to have unique values or we want to have values that appear only once. Now, if you look at here, I have this small list of fruit names. And when I get unique values, I get all the names after removing duplicates. But there's one more way to get data, and that's just by getting the items which don't have duplicacy. So these are the two ways to get data from the unique functions. And we will understand about this argument as well in the examples. Here I have the same list of fruits, and now I'm going to say unique function here, and then I'm going to select this range where I have the names. Now, if I don't specify anything after the array argument and hit enter, I get a simple list of names which are unique after removing the duplicate names. Now, if I enter unique function again and then select the list, and in the BYCOL argument, I have further two options. if I want to have unique values by columns or by rows. Here I have only single column. In that case, I just want to go with the rows. And now when I move to exactly once, the argument exactly once, I get two options further. The one is to return items that appear exactly once. And the second is to return every distinct item. That means after removing duplicates. But when I go with the first option, that's return items that appear exactly once, and close my function and hit enter. That's the same thing that I told you just a few seconds back, that we have items which appear only once. Now here in this data, you can see I have this small table where I have region, month column, January, February, March, and January again. This column, January, is the duplicate column in my data. Now what happens is when I enter unique function and select this data and go to the second argument, that is BYCOL, here I can use the option to return unique columns, and exactly once I'm going to go with return items, return every distinct item. That means every distinct column. Now when I hit enter, now this time when I hit enter, you can see I get region, I get January, February, March, but I don't get the January column, which is in duplicate in the main data here. Now in this example, you can see I have again a small table with employee name, department, city, and salary. Now a few rows I have here which are in duplicate. Now when I enter unique function again and select this data from here, and now in the BYCOL, because I have multiple columns and multiple rows, but I want to get unique data based on the rows. I'm going to go with return unique rows, and then in the exactly once, I'm going to say every distinct item and close this function. Now I get data after removing the duplicate rows. In this case, where I have this entire table, it's not only considering a single value from a single column, but entire row. If that entire row is in duplicate, then it removes that row and give me the unique data from the main data. And in the same way, here I have duplicate values, but I have a row of duplicate values. Now what I'll do, I'll use unique function and select this row. I'm going to go with, because now I have one row, but I have multiple columns. So this time I'm going to say return unique columns, and I'm going to go with every distinct item, close my function. And now here I have a row of unique values, and to just get into a single column instead of row, I'm going to use the transpose function, and I'm going to wrap this entire unique function with the transpose function and close the transpose function and hit enter. And here I have my data in a single column. Now let me start off with the syntax of sequence function. In the sequence function, we have 4 arguments to define, and the first argument, that is rows, is required, and the next 3 arguments, columns, start, and step, is optional. Now, as I said, the whole idea of using sequence function is to generate a sequence of numbers, and then you can use that sequence to generate just serial numbers or serial dates or even some text values. Now, what happens is when we start with the sequence function, in the rows argument, that's the first argument, and required, we need to specify how many rows we want to generate of serial numbers. Let's say if I specify 5, in this case, it will give me 5 values in a serial number starting from 1 to 5. That means when I have 5 here, I'll get serial numbers starting from 1 to 5. That's a simple way of understanding sequence, that with the rows argument, we'll get 5 rows with numbers 1 to 5. Now, if along with the row numbers, if you also specify columns, number of columns, and if I specify 2, in that case, we'll get something like this. Now here you can see I have 5 rows and I have 2 columns, and the total number of values that I have is 10. That means 5 into starting from 1 to 10. And after that, after columns argument, we have the start argument that allows you to specify the value from where you want to start. Normally, when you just specify rows or you specify rows and columns, it starts from the number 1 and then move down one by one from 1, 2, 3, 4, 5. But if you want sequence function to start from a specific number, let's say from 2 instead of 1, you can specify 2 in the start, and then it will start the sequence from 2 to 6. If I specify 5 rows and specify start number 2, it will start from 2 to 6. The next argument is step. You can see here when I specify 5 rows, let's say if I want to generate 5 rows, 5 serial numbers with sequence function, I get 1, 2, 3, 4, 5. Now the step between each number is 1, and that's what we can specify here. By default it's 1, and that's why we are getting number 1, 2, 3, 4, 5. But if I want to have, let's say, step of 2, in that case I need to specify 2 here, and then I'll get values something like this, a sequence like 2 to 4 to 6 and 8 and 10. Now moving back to the start argument, let's say if I want to start from a negative value, let's say I want to start from -5 and my step is 1. You see, I'm starting from -1, but my step is 1, which is a positive number, and that's why it's going back to the positives from -5 to -4 to -3 to -2 to -1. And if I specify, let's say I'm specifying 5 here, my number of rows is 5 here, but if I specify 10, in that case it will move -5 to -4. After -1 it will give me 0 and then 1 and 2 and 3 and 4. And that's how step works. And here in the last example, you can see I have 5 rows. 5 rows here, only 1 column, and now it's starting from -5. But this time, instead of having a positive step, I have a negative step. That means -1 in the step argument, and that's why it is starting from -5, but it's going to -6, -7, -8, and -9, because my step number, the step I have specified, is a negative number. Now let me show you a simple example here. Let me enter the sequence function, and let's say if you want to generate 100 serial numbers starting from 1 to 100, in that case what I'll do, I'll say 10 rows and 10 columns. So you can see I have numbers from 1 to 100. It's kind of a grid of numbers I have. And let's say, let me just change the alignment here. Now let's say if I want it to start from 100 instead of 1, and now when I hit enter, you can see it starts from 100 and goes up to 199. And if I change it from 100 to 101, in that case I get 200. That's how the start number works. And if I say I want to start from -99 and hit enter, you can see it starts from -99 and then go all the way to 0. Because step is positive, but my starting number, the start argument, has a negative 99, -99. And if I specify, because by default the step value is 1, +1, but if I specify -1 here and starting from 99 and hit enter, you can see now it goes up to -198, from 99 -99 to -198. That's how you can control your sequence of numbers using all these arguments. You have start argument and you have step argument to control how you want to generate your sequence. One of the best ways to use sequence function is to generate a sequence of dates. Let's say if I enter sequence and say I need 10 dates, only 1 column, and start is, now here instead of specifying any start number, I'm gonna say this date, and step, which is by default is 1, but I'm gonna specify 1 so that I'll have a serial of dates by adding 1 in every date. Now when I hit enter, I get dates starting from 10th of July to 19th of July. And let me just add 1 here so that I can start from 11th of July to all the way 20th of July 2024. Now let's say if I want to have Step 5, I want to have a difference of 5 days in each date. In that case, I'm going to say 5 here in the step and hit enter. And now I have dates where the date is starting from 11th of July, but I have a difference of 5 days between each date here. Now this is one of my favorite examples of using sequence function where we can generate serial numbers, dynamic serial numbers with a sequence function. So what I'll do, I'll enter sequence here, function, and in the rows, instead of specifying any number, I'm going to enter count a function. And with the count a function, I'm going to select this range and I'm going to extend this range a little bit, let's say up to B100. And now I'm going to close my count a function, sequence function, and hit enter. So you can see I have serial numbers here starting from 1 to 12. Now, as soon as I enter one more name, let's say I get the serial number automatically in the serial number column. Now let's start with the syntax of RANDARRAY function. In the RANDARRAY function, we have 5 arguments to define and all the arguments are optional. Even if you don't specify anything in the RANDARRAY function, you will still get a random number, but that random number will be between 0 and 1. So let's start with the arguments. First of all, we have rows and then we have columns. Now these two arguments are basically the number of rows you want with the random numbers and number of columns you want with the random numbers. So if I specify, let's say only 5 rows and 1 column, I'll get something like this. Random numbers, 5 random numbers in 5 rows and 1 column. And in the same way, if I specify 1 row and 5 columns, in that case, I'll get a single row with 5 values. So this is like how it is in vertical way and horizontal way. So you can decide how many rows and how many columns you want with the random numbers. Once you specify the row numbers and column numbers that you want, after that you have further 2 more arguments where you can specify the minimum value and the maximum value. So it's like a range from which you want to get the random numbers. So if you specify 1 and 100, in that case, you get all the random numbers between 1 and 100. Now moving ahead, we have the 5th argument, that is integer. Now what happens is when you generate random numbers with the rand array, you actually get numbers with decimal part. But with the integer argument, you have this option to choose if you want the decimals or you don't want the decimal. You just want the integer in the random numbers. So that's something you can do with the integer argument. Now there's one more thing that you need to understand, and that's about the min and the max argument. The value in the min needs to be lower than the max, and the value in the max needs to be higher than the min. And if somehow by mistake you enter the wrong values here in the min and max, you will get a value error in return. And there is most important point about RANDARRAY function is that RANDARRAY is a volatile function. So when you use this function to generate random numbers and then you update anything in your worksheet or you recalculate anything in your worksheet, in your workbook, it will regenerate all the random numbers again. And if you want to get the random numbers with RANDARRAY function and do not want these numbers to regenerate itself, you don't want RANDARRAY function to regenerate those random numbers, the best way is to convert those numbers into hard values. So I'll show you that also in the example. So let me generate some random numbers here. I'm going to say RANDARRAY, and when I don't specify anything and hit enter, I get a random number between 0 to 1. That's what I told you at the very beginning of this video. But let me enter the RANDARRAY function again. And now let me specify 10 rows and 5 columns. And the minimum value is 100 and the maximum value is 1000. And let me close and hit enter. And you can see now I have 50 random numbers where I have decimals as well. And when I go back to my function, and from the integer argument, as I said, we have this option to choose decimal part, that we want to have decimal part with the random numbers, which is false, and by default this is the option. If you don't specify anything in the integer argument, the by default is the decimal numbers. But if I want only integers, I'm gonna go with true and hit enter, and here now I have random numbers, 50 random numbers between 100 and 1000. And you can see that when I entered this formula here, my value from this cell also changed. And that's because RANDARRAY function is a volatile function. Now I have my random numbers and I want these random numbers to not to change. What I'll do, I'll just copy it, the entire range, right click, go to paste special, click on values and click OK. And now my numbers are hard values. And you can see this formula where I have RANDARRAY function, I still have RANDARRAY function, is changing the value after the every update that is happening in my worksheet. Now let's say I want to generate random numbers for 5 columns and 5 rows. And I have a value here. This is more about an error that you're going to get. That's the spill error. I have a value here. Let's say I have a name here. And here in the cell A1, I am entering this RANDARRAY function and I'm saying I need 5 rows and 5 columns. 100 is the minimum and 1000 is the maximum, and I want only integers. So when I hit enter, this time I get this spill error, and that's because I have a value here. If you look at the spill error here, the expected range to generate these random numbers is from cell A1 to E5, and I have a value in between this range. So that's the reason I'm getting the spill error. Now when I delete this value, I get my random numbers, the array of random numbers in return. Now one of the cool ways to use the RANDARRAY function is to generate random dates between two dates, start date and end date. So what I'll do, I'll start with the RANDARRAY function. Say I want 5 rows and 3 columns. The minimum is the start date, the maximum is the end date, only integer. Close the function and hit enter, and now I have total 15 random dates between 1st January 2024 to 31st March 2024. Alright, so let me start off with the syntax of MAKEARRAY function. Now in the MAKEARRAY function, you can specify the rows and columns. So these rows and columns are the number of rows and number of columns that you want to have in the result array. So if I want to specify, let's say 10 rows, in that case, this number will go to my rows argument. And if I want to have 2 columns in the array, this will go to my columns argument. And in the third argument, that is function, it is calculation that I can perform using the lambda function. Now in this example here, you can see I have 10 rows and I have 2 columns. Now the calculation, the result I have got in this array is basically using the row numbers and the column numbers. Now in the first cell, you can see here I have this value 2, which is basically 1 plus 1. So the 1 is row number, and then the second one is the column number. And the same way, when I move to the second cell, that means I'm moving to the second row, which goes second row and the first column. And that's why I have 3 in the result. And this goes up to total 10 rows. And then it moves to the second column where I have the first row and the second column, and I have 3 in the result. And this calculation goes down to the 10 rows in the second column. And that's how I get all these values in this array. Now the point is, even though you can use lambda function in the function argument, you can only use row numbers and column numbers in the calculation. So let me show you a simple example here. I'm going to enter MAKEARRAY function, and in the rows, I'm going to say 10. I want 10 rows, and in the columns, I want 2 columns. It's the same example that I have just showed you. And in the function, I'm going to go with the lambda function. And in the lambda function, I'm going to say R for rows, and C for columns. And in the calculation, I'm going to say R plus C, that means row number plus column number. And when I close lambda and then close make array, you can see I get the exact same array that I have showed you a few seconds back. Now let's say if I change this calculation, instead of adding row and column number, if I concatenate them, so you can see in a better way how these numbers comes up in the calculation. So I'll say an ampersand, hyphen, and then again an ampersand. So it will, instead of summing it up, it will combine the row number and the column number. And now when I hit enter, you can see I have row numbers and column numbers in the array. So this is first row, first column, second row, first column, and then up to 10th row in the first column. And the same way, first row, second column, and 10th row in the second column. And that's how you get values in the calculation from the row numbers and the column numbers. Now, what's the practical way of using make array function? So here I can generate invoice numbers using this text inv and hyphen before invoice number. So for this, I'm going to say make array and rows, because I want to add 50 invoice numbers. So I'm going to say 50 in the rows and 1 in the columns. And in the function, I'm going to enter lambda. And in the lambda, again, R and C. And in the calculation, I'm going to go with the simple text that says inv and hyphen and combine it with my actual calculation, that is text. And I'm going to use the row numbers in the value, and I'm going to format it with 4 zeros. So I'll say 0, 0, 0, 0. So this way I will always have a number with 4 digits. If the number is 1, I'll have 3 zeros, leading zeros. And if I have, let's say 10, I'll have 2 leading zeros. Closing the text function, closing the lambda, and my make array function. Now when I hit enter, you can see I get these invoice numbers starting from 1 to 50. So that's one of the practical ways to use the make array function. And here I have one more example to use make array function. Now here I have this sitting plan that I have got using the make array function. So let me show you how it works. But before that, let me show you a simple function that I'm going to use with make array function, and that is the character function. So when I enter char, it is a character function that allows you to get a character based on a number. So when I enter 65 in this function and close this function and hit enter, I get a in return. And when I say 66, so the point is starting from 65 and to the next 25 numbers, I can get the alphabets from A to Z. So if I say 65, 64 plus 25 and hit enter, it gives me Y. And if I say 26, which is the total number of alphabets we have, it gives me Z. So this is the range of numbers that I can use to get alphabets in return from the character char function. Now what I'll do, I'll use this function with the make array function to get this sitting plan. We'll enter make array function. We'll enter make array function, and I'll specify I need 5 rows and I need 12 columns. And in the function, I'm going to go with lambda, R for rows and C for columns. So these are the 2 parameters that I have. And now I will start with my calculation. Char function starting with 64 plus the row numbers. So it will give me 65, 66, 67, 68, and 69. Closing the char function, and then, I need to enter an ampersand, a hyphen, to have between the alphabets and numbers. And then I'm going to enter text function and using column number here and formatting it with 2 digits. Closing text function, closing lambda, and make array. And here I have my sitting plan starting from A01 to E12. All right, so now let's start with the syntax of toCall and toRow functions. Now the whole idea of using toCall and toRow is to convert an array where you have multiple rows and multiple columns into a single column or a single row. You can see here I have this data here where I have names in 4 different columns and 5 different rows. And by using to call, I was able to convert this array into a single column, and by using to row, I was able to convert this into a single row. Now in this syntax, first of all, we have array. That's the original range where you have your values, the actual array. And after that, we have ignore argument that allows you to ignore empty cells, error cells, or if you want to ignore both errors and empty cells, or if you don't want to ignore anything. That's kind of options you have that you can choose in the ignore argument. And after that, we have this third argument, that is scan by call. Here we have two options. When you converting your array from multiple columns and multiple rows to a single column to single row, how you want to convert it. Let's say you want to go row wise or you want to go column wise. This way it will take values from each row one by one, or with the other option, it will take values by column one by one. And that is something that you can specify in scan by column argument. And here I have this same data, same list of names in 4 columns and 5 rows. I'm going to enter to call function here and specify this array. And then again, when I move to ignore argument, as I said, we have 4 options. The one is to keep all the values by default, and then ignore blank cells, ignore errors, or ignore blanks and errors. So I'm going to go with the last one. And then when I move to scan by column, I have 2 options. One is to scan by row and the second is to scan by column. Let me go with the scan by column and hit enter. And you can see I have all the values from this array in a single column. And because I have specified scan by column, the data that I have here, you can see the first 5 values is from the first column, and then from the second column, and then from the third column. That's how it's scanning the data to give me a single column. And the same way I can use to row function and specify the array here and ignore blank and errors, and then go to scan by row this time, which is by default. If you don't specify any value, it will take that option. And let me close it and hit enter. Now you can see I have all the values from this array in a single row. And because I have specified scan by row, I have data from the first row, and then from the second row, from third row, fourth row, and then fifth row. Now here in this data, I have a few blank cells, and I also have one cell with not available errors. So when I enter to call and specify this array, and then in the ignore argument, if I don't specify anything, if I go with keep all values, that is by default, and then I go by scan by row and hit enter, you can see I get the values, but I also get, these blank cells where I have 0 and then the cell with the error as well. That's how you can use ignore argument to ignore empty cells and errors. I'm going to go with the fourth option and scan by column this time, close my function and hit enter. And now I have total 17 values in the new column where I had total 20 cells in this array. It is ignoring the blank cells and the error cells. The same thing goes with the to row function. Here I have a single row without blank cells and the error cell. Let me start off with the syntax of HStack and VStack. The whole idea of using HStack and VStack is to stack your multiple arrays into a single array. Horizontal means in a single row and vertical means in a single column. You can see here, this is where I'm using the VStack function, and I was able to stack these 5 arrays from here, from here, from here, and here to this. And in the same way, by using HStack, that is horizontal stack, I was able to stack all these arrays where I have data into a single row. Now in both the functions, you can specify up to 254 arrays, and it will use the sequence of arrays that you specify. So if you specify this array first in the array 1, and then this array in the array 2, and this array in the array 3, so it will use that sequence to stack your data in a single row or in a single column. So let me move to the example. I have the same data here, and I'm going to use VStack. That means vertical stack. So I'm going to select my first array and then move to second, and then third, and then fourth, and then fifth. And now I'm going to close my function and hit enter. And here I have my data from all the 5 arrays into a single array. You can see this is the first, the array I have specified, and then with this value from the second array, which is just below the first array in the single column. And the same thing goes with the edge stack, that is for horizontal stack. I'm going to select first one, and then the second one, the third one, and fourth and fifth. And now I'm going to close my function and hit enter, and I have all the data, all the 5 arrays into a single row. Now let me tell you a real life example of using VStack and EdgeStack function. Here I have 4 worksheets where I have data for 4 weeks. Now what I'm going to do is I'm going to use a range of worksheets and range of cells to stack this data vertically. So I'm going to say VStack, and after that I'm going to go to week 1 worksheet, and then by using the shift key, I'm going to click on week 4. So you can see I have this range of starting from week 1 to week 4. And now I'm going to say from A2 to D4. And now I'm going to close my VStack function and hit enter. And now I'm into my example 2 worksheet, which is the main worksheet that I have, and my data from all the 4 worksheets is now in my main worksheet. So that's how you can use VStack function to stack your data even from multiple worksheets. Now the same thing you can do with the EdgeStack function. So here again I have 4 worksheets with quarter-wise data, and I have data for 3 months in the each quarter. And in the main worksheet, I'm going to say EdgeStack, and again I'm going to go to the first worksheet, press and hold the shift key, and then select the last one. And then I'm going to select A1 to C2, and I'm going to close my function, hit enter, and here I have data from all the 4 worksheets stacked into 2 rows horizontally in 2 rows. Let me start off with the syntax of wrap calls and wrap rows functions. And in these 2 functions, we have identical arguments, and the first 2 arguments, vector and wrap count, these 2 arguments are required, and the last one, that is paired with, is optional. Now, as I said, the whole idea of using wrap calls and wrap rows functions is to wrap your data from a single dimensional list to multiple columns or multiple rows. So when you use, let's say, wrap rows, as I have used here, I have this list of values, which are basically numbers. I can wrap this list into multiple rows. I have value 1 here, and 2, and then here in the next row, I have 3 and 4. And after every 2 values, it is moving to the next row. And now what happens is, in the vector, when I specify this range where I have the numbers, in the wrap count, I have specified the number 2. So that's the reason here in each row I have 2 values, and then it's moving to the next row. So this count in the wrap count, this number in the wrap count decides how many values it will wrap in a single row, because I'm using wrap rows, and this count decides how many values I will get in a single row. And after every 2 values, it's moving to the next row, and then 2 values, next row, 2 values, and then next row. And this is how it is restructuring my data from a single dimensional list to multiple rows. Now the same thing goes with the wrap calls. We have vector, wrap count, and paired with. Now in the vector, again, I specify this list where I have 1 dimensional data, and when in the wrap count, I say 3. Now here you can see, because it's wrap calls, and that's why it works as columns. So in the first column, I have 3 values because I'm specifying 3 here. 1, 2, 3, 3 values, and then it's moving to the next column. And again, 1, 2, 3. Again, next column, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, when it moves to the next column, where I have only one value left, that's 16, the next two cells are blank. Now, here's this value that says no value. I'm getting this value from the pad width argument. I have specified this value in the pad width, and that's the use of pad width argument. When you restructure your data and you don't have value for some last cells in a column or in a row in both the functions, you can specify a value in the pad width, and that value will be shown all the cells which are left with no value. So let me just move to the example. Here we have the same data, and let me just enter the wrap rows function first. Select this list, and in the wrap count, I'm going to say 2. And in the pad width, I'm going to use a hyphen and close my function. So you can see the same thing. I have 2 values in the each row because my wrap count is 2 here. And when I change this wrap count from 2 to 3 and hit enter, now I have 3 values in each row, and that's how it is moving to next row after every 3 values. And when it finishes the list of values that I have specified for all the cells where I don't have any value, at the end of the rows, we have the value that I have specified in the pad width argument. Now the same thing goes with the wrap calls. Let's say wrap calls, select my vector, the list of numbers, and then wrap count, I'm going to go with 3. And in the pad width, I'm going to say no value. And when I close it, I get 3 values in the each column. Let me change the width here. Let me just change the alignment. And now you can see I have this array here. Now when I change this wrap count from here, let's say from 3 to 2, now I have 2 values in each column. So that's how it is actually moving with each value. First value, second value, and then move to next column with the third value and fourth value and fifth and sixth. And here you can see I don't have any blank value at the end. And that's why I have no pad width value, because there is no cell left with a blank value. That's how these two functions work. You can restructure your data from a single dimensional list to multiple rows and multiple columns. And you can also specify a pad value to deal with the cells which are blank. So let me start off with the syntax of both the functions. Now in the choose call and choose rows functions, we have identical arguments, and we have 2 required arguments first, and then we can extend the second argument 252 times more. Total, we have 253 arguments that we can extend, but the first argument is required, and after that, further arguments are optional. Now the first is the array, and in the choose rows, we have same argument array, and array is basically the data that you want to refer to. And in my case, if I specify to this data that is from cell A1 to D6, this will go to this argument array. Now after that, let's say if I want to extract this row, which is the third row, in choose rows function, I'm going to specify 3 here in the choose num1 argument. And if I want to extract, let's say, first column, I need to specify 1 here in the column num1 argument. And after that, I can extend. If I want to extract more columns, I can keep on adding the column numbers and keep on adding the row numbers if I want to extract more rows. So that's the whole idea of using these two functions, is to extract specific columns using column numbers and specific rows using row numbers. Now here I have the same data, and when I enter choose rows function and specify my array, and then I specify, let's say, 3 and close my function, you can see I get the third row from this data, which is the name Oliver Smith, UK, age 34, and London. In the same way, if I enter the choose calls function and specify my array, enter the column number, let's say 1, I get the first column. Now, if I want to have more than 1 columns, so what I'll do, I'll go to the second column number, column num second argument, and specify the second number of the column that I want. Now I'm saying first and the fourth. And now when I hit enter, I get name and city. And name is the first column and city is the fourth column. And the same thing goes with the choose rows. I want third row and then I want the sixth row. And here I have third and the sixth row. Now there is one more way of specifying the rows and the column numbers. Instead of specifying these, row numbers in different arguments, you can also use two curly brackets, and then within these curly brackets, you can specify your row numbers. Let's say if I go with 1, 3, and 5, and then if I close my function, you can see I get the first row, which is the heading row, and then the third one, and then the fifth one. And the same thing goes with the choose calls function. Curly brackets, let me enter first and third, closing curly bracket, closing the function, and hit enter. And here I have name and age from the main data, the column first and the column third. Now here's a real life example where you can use choose rows or choose calls function. I have this data here where I have dates and names and then sales amount, and I want to extract the last row from this data. So I'm going to say choose rows and specify my array that I have. And now in the row num1 argument, instead of specifying the row straight away, because I don't know how many rows I have, maybe it will increase in future. What I'll do, I'll use the count a function. I'm going to say count a, and this is the column, and then close the count a function, close my choose rows function, and hit enter. And now I have the latest row from the data. And I can do one more thing. Let's say if I want the second last row, I'll say -1 and hit enter. And now I have the second last row from the data. And here I have a really interesting way to use choose calls function. I'm going to enter choose calls function here, and I'm going to specify the array. And this time I'm not going to include the row with the headings. And in the column num1 argument, I'm going to go with 1 because I need the month column. That's the first column. And in the column num2, I'm going to enter a function, and this function is XMATCH. Now here XMATCH will help me to identify which column I want using the value I have in the cell J1. So if I enter Jan here for January, I'll get data for January only. And if I specify Feb, I'll get data for February only. That's something I want. So I'll say XMATCH. This is my lookup value, and this is my lookup array, and match mode is exact match. And now I'm going to close my function XMATCH and close my choose calls function. Now you can see I have January here, JN, and that's the column that I have here. Now the moment I change it, let's say from January to, if I go to my MAY, and I get data for my. Now this is something very, very useful if you want to create dynamic charts. What I'll do, I'll go to insert and then create a simple 2D bar chart. And let me just paste it here. And let me change its size here. And now what happens is when I change month name here, let's say instead of my, I'm going to go with Feb. Now I have a dynamic chart, and it's very, very easy to create these kind of dynamic charts with choose calls and choose rows functions. All right, so now let's start with the syntax of drop and take functions. Both the functions have identical arguments. The drop function, you can drop in number of rows and columns, and with the take function, you can take number of rows and columns. Let me explain the syntax argument by argument. Now, first of all, we have the array argument that we have in both functions, and then we have rows, columns, columns. Now, let's say I have this data here, which is my main data, and I want to drop last 3 rows. So what I want here, I want to have this part of the data by removing last 3 rows. What I'll do, first of all, in the array, I'm going to specify this entire data, and in the rows, I'm going to say -3. Now here, the -3 means 3 rows from the ending of the data, and that's why I'm saying -3. And if I have to drop 3 rows from the starting of the data, in that case, I would say 3. That's the difference between positive and negative number. Now, along with these 3 rows, which I'm dropping from the ending of the data, I also want to drop the last column. My data will look something like this, only this part. Now for this, in the columns argument, I'm going to say -1. That means one column from the ending of the data. And it will return only this part, the first column, second column, and removing last 3 rows. So this was the drop function. Now in the take function, which is exactly opposite of the drop function, again, as I said, we have 3 arguments: array, rows, and columns. Now let's say if I specify this range, the entire range that I have here in the array. Now let's say if I want to have first 4 rows, heading row and 3 rows from the data. In that case, in the rows, I'm going to say 4. That means I want 4 rows from the starting of the data. And if I want 4 rows from the ending of the data, in that case, it will be -4. This is exactly opposite of the drop. So instead of specifying how many rows you want to drop, you are specifying how many rows you want from the data. Now in the columns argument, which is optional argument, if you don't specify anything, it will completely give you 4 rows with 3 columns. But if you want to have specific number of columns, let's say you just want the first 2 columns, you don't want the column that you have at the end, in that case you'll say 2. That means first 4 rows and the first 2 columns. So that's how you specify number of rows and columns in drop and take function to get or drop the data the way you want. Now let me use a simple example. Let me use the same data and show you how to use these 2 functions. So when I say drop function and specify this array here, let me just start from the data without headings. Now in the rows, I'm going to say I want to drop first 2 rows. That means 2, positive 2, because I want to drop it from the starting of the data. And then columns, I'm going to say drop last 2. Let's say the age and the height. So what I'll say -2. That means 2 columns from the ending of the data. Let me just close my function and hit enter. You can see I get only the name column, but I don't have the first 2 entries here. And I don't have the age and height column here. And if I just remove this columns argument and hit enter, now I get data starting from the 3rd row from the data, and I get age column and height column. That's how you can specify number of rows and columns that you want to drop. Now in the same way, let's say if I want to use the take function, again I'm going to specify the array and then number of rows that I want. So I'm going to go with rows from the ending of the data. So I'm going to say -2, and I'm not going to specify any columns because I want all the columns. Here I'm going to hit enter, and here I have 2 entries, 2 rows from the ending of the data. That's these 2 rows with all the columns. But if I specify, because columns argument is optional, when you don't specify anything, that means the function will consider all the columns. But if you specify anything, let's say if I specify 2, positive 2, and hit enter, in this case I get names, I get age, but I don't get the height because I'm specifying I only want the first 2 columns. In this example, I'm going to show you a simple formula that you can write and use in the real life. Now here you can see I have date, quantity, and amount in this 10 entries. Now here I want to have last 5 rows, but I want to ignore the latest row. So the whole idea is to get data for these 5 rows, but ignore this row. Ultimately, I'll get 4 rows. For this, what I'll do, first of all, I'll use the take function and specify the array that I have here, and then I'm going to say -5 rows. That means 5 rows from ending of the data. And I'm going to close this and hit enter. Now I have data for 6th of October to 10th of October, but I don't want the last row as well. So what I'll do, I'll wrap this take function with the drop function. Now the array that I'm getting from the take function, where I have 5 rows, now I'm going to say drop the last row. That's the latest row that we have in the take function. And here I'm going to close my function and hit enter. And here I have 4 rows from 6th of October to 9th of October. Let me start off with the syntax of expand function. Now in the expand function, we have total 4 arguments to define. And out of these 4 arguments, the first argument is required and the next 3 arguments starting from rows to pad with, these 3 arguments are optional. Now what happens is when you use expand function, as its name suggests, expand function allows you to expand an array. Now say if I have this array here where I have 3 columns and 3 rows, and I want to expand this array from 3 columns to 4 columns and 3 rows to 5 rows. In that case, what I'll do, I'll specify this array in my expand function in the array argument, and in the rows, I'm going to say 5 because I already have 3 rows and I want to expand it to 5. That means I'm adding 2 more rows, but the total count of the rows will be 5. And that's why I'm specifying 5 here. And after that, in the columns, I already have 3 columns and I want to have 1 more column. That means total 4 columns. So I'm going to say 4 columns here, 5 rows and 4 columns. Total number of rows, total number of columns. And after that, pad with allows you to specify a text or a value that you want to have in the expanded part of the array. So when you expand this array to this array, you can see here I have these hyphens here. That is the value I added in the pad with. Normally, when you expand an array from this to this, you get not available error in all the newly added columns and rows. And by using pad with, you can specify a value or anything that you want to have in those newly added rows and columns. Now here I have the same data, small data, 3 rows and 3 columns. And when I enter expand with function here and specify my array and then say I want to have 5 rows and 4 columns. Oops. And 4 columns here. And when I hit enter, you can see I get all the values from the original array. And now by expanding this array, I do get 2 more rows and 1 more column, but I have not available error here. So what I'll do here, I'll go to the pad with argument and I'll specify a blank here. And when I say blank, now I have a new array where I have all the original values and I have 1 more column and 2 more rows here. And when I go back and instead of a blank value, I'm going to say I need a hyphen and hit enter. Now this time I have hyphens for all the newly added rows and columns. Now here in this example, I'm going to show you where this expand function fits while using with your data. You can see here I have this small data here, day names and staff names, and I have staff's name for each day. And for some of the days I have 3 names, and for some of the days I have 2 names, and for Monday I have 1 name. Now let's say if I enter this text split function that allows me to split this data, I select this cell and I say my column delimiter is a comma and a space. And when I hit enter, you can see I get value from the cell. And when I drag this formula down, I get values for all the days where the staff is either have 2 names or 3 names or 1 name. I'm getting the data. Now, let's say when I enter expand function along with this text split, and I have array from the text split function itself. And now in the rows, I'm going to say, now in the rows, let me just skip it and move to the columns argument. And here I'm going to say 3 and hit enter. Now, again, I have the only 1 name that I have for the Monday, and for the rest, I have not available error. But what I'm going to do is in the pad with argument, I'm going to say TBA, to be appointed, and I'm going to close my function. And now let me just drag this function as well for all the other days. And now I have an array where I have all the names for all the days, and I also have this value TBA that will change when I enter a name here. Let's say if I enter one more name, let's say if I enter my own name, you can see I get this name splitted into the second column, and I still have this value TBA that will again change when I enter or update anything in this column where I have staff's name. Alright, so let's start with the syntax of TRIMRANGE function. Now, before we jump into the syntax and the arguments of the TRIMRANGE, let me show you how TRIMRANGE function works and how we can specify values and use syntax of the TRIMRANGE to get our desired result. So you can see here I have this range here, and when I use this range address, that is from F2 to I5, when I use this address as it is, I get this range back, but I get 0 for every cell where I don't have a value. That means for blank cells. You can see 0 is here, 0 is here, 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 and here too. Now, by using TRIMRANGE function, I can trim the blank cells from the top of the data and from bottom of the data and from the right side and left side. So you can see when I used TRIMRANGE, all the blank cells which I have here we have zeros for that, but in this result where I have used TRIMRANGE, I don't have these blank cells. I don't have zeros that I have here. I have straight away the 4 cells where I have the values. And that's something you can do with the TRIMRANGE function. Now, how we use TRIMRANGE function? First of all, we have range. That's the range. We have the original range where I have values and blank cells, blank rows, this leading blank row, trailing blank row, and leading column, blank column, and trailing blank column. Now, in the second argument that says row trim mode, here in this argument, when you move to this argument, it gives you 4 options. The one is you don't want to trim anything, or you want to trim the leading row, or you want to trim trailing row, or you want to trim both. You want to trim this row and this row both. And after that, when you move to column trim mode, it also gives you the same 4 options: none, leading column, trailing column, and both. So this way you can trim these blank cells and these blank cells as well. Now, apart from TRIMRANGE, we also have a trim reference. You can see here, this is an example of using trim reference shortcut. Now you can see when we specify a range, let's say if I am specifying the range starting from F2 to E5, we have this colon here in between the starting cell and the ending cell. But in the trim reference, you can add a dot like this and then a dot like this. So when you add a dot before the column, that means you want to trim the first column and the first row. That means the leading column and the leading row. And when you add a dot after the column, that means you want to trim the trailing row and the trailing column. And it doesn't matter how many blank columns you have at the end or at the starting. If you use this reference or if you use the TRIMRANGE function, it will remove all those columns and all those rows which you have leading and trailing. Now let me show you the same thing using an example. When I enter trim range and select this range, and then I move to the second argument, that is row trim mode. I have 4 options: none, leading, trailing, and both. I'm going to go with both. And same for the call trim mode. I'm going to go with both, close my function and hit enter. And now you can see I only have values after trimming leading and trailing column and leading and trailing rows. And if I use the trim reference shortcut. So what I'll do, I'll specify the range as it is. And after that, I'm going to say leading row and leading column, and then trailing row and trailing column. And now when I hit enter, I get the cells where I have the values. That's how you can use trim range function and trim reference shortcut. Now let me take you to an example to show how trim range function is actually useful when you're working with data. So here I have this small region-wise, salesperson-wise, product-wise data where I have units and unit price. Now when I calculate revenue using unit and unit price, I need to write a simple formula of multiplication. And then I need to drag this formula down. So that's the simple way. But if I want to have single formula for entire calculation for the entire column, in that case, I can do something like this. That is selecting the entire units column and then selecting the entire range actually, and then the entire range for unit price and hit enter. I again get the column of revenue. But the problem is if I add new value here, in that case, this formula will not extend itself. I need to change the reference in the formula. Now, if I write formula in a different way, let's say if I extend my range from here, let's say if I go to at least E100, and then if I say F100, this way I will always have the revenue. When I add a new unit, I'll create a new entry for units and unit price. But the problem is I have this long column with 0 for all the blank entries. Now this is the point where you can use trim range function. So what I'll do, I'll wrap both the references with trim range function, trim range, and then I'm going to say close. I'm not going to specify any argument after the range because by default trim range function trims the leading and the trailing rows and leading and the trailing columns. So I'll say one more trim range, close the function and hit enter. And here you can see I have my revenue column and formula is working for the range from E2 to E100, but I don't have those zeros here. And when I enter, when I create a new entry, let's say if I say 20 units and 50 is unit price, I get the revenue here instantly. In this example, we're going to join data from multiple worksheets into a single worksheet. And this is one of my favorite examples of using trim range function. Let me take you to all the worksheets that I have. You can see here I have data for north, west, east, and south. Now, if I want to join this data in a single worksheet, I'm going to use this function called vstack. So I'll click on north worksheet and then I'll press the shift key and then click on south. So now I have a range of worksheets, and after that I'm going to select a range, let's say starting from A2 to H20. I'm going to close the function and hit enter. Now I have data from all the 4 worksheets, but the problem is with this data I also have some blank rows, and these blank rows basically have zeros. Now the reason is in all the 4 worksheets, the length of the data, the height of the range is different. In one worksheet, I have total, say 16 rows for data. In one, I have 13, and then I have 17, and then I have 4. And that's the reason when I'm using the exact same range reference for all the 4 worksheets, I'm getting a few blank rows. Now to deal with this problem, we're going to use trim range function. So I'll quickly add the sort function first so that I can sort my data. I'm going to say sort with the first column, that's the date column, and hit enter. Now my data is sorted and all the blank rows, all the zeros, those rows with zeros, I have in the trailing. And now I'm simply going to say trim range and wrap this entire formula with trim range, close the function, hit enter, and here I have my data joined from 4 different worksheets without blank rows. Now let me start off with the syntax of MAXIFs and MINIFS functions. Now the whole idea of using MAXIFs and MINIFS function is to get the maximum value or the minimum value based on single or multiple conditions. Now let's say we have this data here where we have names, we have department, salary and year. Now in the MAXIFs and MINIFS functions, we have total 3 arguments to define. The max range. Now this max range, or in the MINIFS function, this is min range. This is a column where you have values for which you want to get result in the end. Let's say if I want to know maximum salary based on a condition or minimum salary based on a condition, in that case the salary column will go to the max range or the min range. That's the basic, or I would say the starting of my entire calculation. That's the column from where I'll get value in the return. Now we have 3 arguments in both functions, but you can extend the last 2 arguments 126 times. Now what happens is in the range 1, when we specify the max range or the min range, that's the column where we want to have the value in the end. After that, we need to specify a range, or I would say a column from where we want to test our condition. After specifying salary, if I want to know the maximum salary for the year 2023, and here I have this column where I have years. This column will go to the range 1, and the condition that says 2023 or 22 or 21, that means 2023, 2022, 2021, that's the condition that I want to use. That condition will go to the criteria 1. This is one pair of the condition column, range 1 and criteria 1. And this way we can specify total 126 pairs of criteria column and the criteria. And here I have same data, name, department, salary and year, and we going to use MAXIFs and MINIFS functions to get some of the conditional maximum and minimum values. First of all, I'm going to start with MAXIFs, and I want to know the maximum salary in the sales department. I will go to the salary column, and in the max range, which is the value range, I'm going to select the entire column, and then I'm going to press Control Shift and equals to come back to the current cell. That's the shortcut key that you can use if your data selection is quite large and your screen moves down or moves up and you want to come to the current cell where you are entering your formula. You can use the keyboard shortcut Control Shift equals. The next thing is to specify the range from where we want to test our condition, the criteria range. So I'm going to go with department, and again Control Shift equals, come back, and after that I'm going to specify my criteria 1. That's the condition, and I'm going to select the cell F2 where I have the name of the department, and now I'm going to close my function and hit enter. So it says 79332. That means that's the maximum salary in the sales department. And let me just write the MINIFS, and I'm going to go to salary column again, come back, criteria range department, come back, and I'm going to select the sales here, the sales department, and now I'm going to hit enter, and 43416 is the minimum salary in the sales department. So let me just verify it here. Let me just filter the sales department. Let me just sort this data and use salary, largest to smallest, click OK. And now when I filter sales, just to test or verify the result I have, it says 79332 and it also says 43416. That means my result here for the MAXIFS and MINIFS is correct. Now let's say if I want to have more than one condition, I'm going to say MAXIF, and now the condition is to get salary for marketing department, but for the year 2021. Again, I'm going to say this is my max range, and this is my criteria range department, and here I have criteria, the department name, and now I'm going to specify one more criteria that is for the year 2021. I'm going to say this is my criteria 2 range, and the criteria 2 is here, that's 2021. And now I'm going to close my function to get the result, and same thing goes with the MINIFS. Again, even though if I don't want to write this function, I'll just copy MAXIFS, and I'm going to say, and I'm going to paste it here and change the name, just the name, because all the arguments are identical and my references are already there. And now I'm going to hit enter to get the result. Now let's say if we want to specify a condition where we want to exclude a particular value. Let's say if I want to know the maximum salary or the minimum salary by excluding finance department. I want to know maximum salary from all the departments, but not from the finance department. In that case, what I'm going to do is I'm going to say max ifs. This is my max range, and in the criteria range 1, I'm going to go with department again, and then in the condition, in the criteria 1, I'm going to say not equals to, and then an ampersand, and here's the name of department that I want to exclude. And now I'm going to close my function and hit enter, and here I have my result 79332. Let me just verify it. Let me just exclude finance department here, and you can see that salary, the highest salary from all the departments other than finance is from the sales department. That's 79332. And let me come back to my formula. Let me copy it from here and change it to MINIFS, and hit enter. And here I have my minimum salary excluding the finance department. Let me verify it as well. Let me go to the and exclude finance department. Let me go down, and here I have the salary from IT department. That's the lowest, or I would say minimum salary from any department other than finance. And now the same thing we can do by excluding a year. So I'll say max ifs, and then the salary here, and then my criteria 1 range, that's the year column, and again double quotation marks because I'm specifying not equals to. So I'll go with both the lower than and greater than sign, and then enclose these two sign in double quotation marks, and then ampersand to combine it with the year 2022. That's the value I have in the cell F15. And now here I'm going to close my function, and here I have my result. And let me go and do it for MINIFS as well. And here we have the minimum salary. Let me just verify it for you. Let me exclude 2022 from the list, and here I have the maximum salary 79507. That's correct. And then we have the minimum salary 40338, and that's what we have in the minimum salary. Let me start with the syntax of %of function. In %of function, we have two arguments to define: data subset and data all. In the data subset argument, this is a single value or a range of values or an array of numbers representing a part of the total, and for which you want to calculate the percentage. Here I have this value, a single value 10. And after that, in the second argument, that is data all, this is the list of values from a range or an array of numbers representing the whole of the data. Now, if you look at here, I have these three values 10, 20, and 30, and the total is 60. And in my case, this is the data all. This range where I have numbers is data all, and 10 is the subset for which I want to calculate the percentage. Now let me quickly show you how to use the %of function. When I enter the %of function and select the data subset, and here I'm selecting the January month, the quantity for the January, and then in the data all, the entire 12 months of quantity, and close my function, hit enter, and here I have 0.085. That's the number because my cell doesn't have the percentage formatting. So what I'll do, I'll select Control Shift and percentage to apply the percentage formatting. Now let me show you a little more real life example. Let's say if I want to have a running total of percentage for each month, I can use the %of function. What I'll do, I'll enter %of function, and in the data subset, I'll select the first 2 months, that's January and February, and then the entire range of the quantities for 12 months. Now, before I hit enter, let me freeze the first cell here, that's P2. Let me enter a $sign and also the entire range of quantities. I'm going to press F4. Now, when I hit enter, you can see I get 0.14 and I need to apply the percentage formatting. I'll press Control Shift and percentage. And now I'm going to drag this formula down up to the month of December. And here I have my running percentage month on month. Now, even though the %of function is quite useful when you want to calculate the percentage, but the real use of %of function is with other functions. Now, there are two functions which are really amazing when you want to create summary tables, that's GROUPBY and PIVOTBY. And within these two functions, we have inbuilt %of function. So when I enter GROUPBY and select my row for which I want to create the summary table, and then I go to the values. Let me go back and select, let's say, quantity. And now when I move to function in the GROUPBY function, the function argument, you can see I have this function to use, that is %of. When I select this and close my function here, this time instead of getting the total quantity for the each category, I'm getting the percentage of that category from the total. That's how the real use of %of function is within the GROUPBY function. It says 26.7% for accessories and 38.2% for bikes and 35.1% for clothing for the 100%. And in the same way, you can use %of function in PIVOTBY as well. When I enter PIVOTBY and select my rows field, that's country, and then go to category, and the values is again units. And in the function, again, I'm going to go with %of, close my function here. Let me just change a little bit. Let me say not to show field headers and close my function. And here I have, again, let me just apply percentage formatting. And I have this percentage summary table with percentage of country wise and category wise to the total. Accessories here is 27% out of total 100% for all the 4 countries. And then bikes, where Australia is 19%, United Kingdom is 2%, India is 30%, and then United States is 49%, comparing to the total of 100% for all the bikes. That's the different way of using %of function with GROUPBY and PIVOTBY function. Let me start off with the syntax of GROUPBY function. Now in the GROUPBY function, we have a long list of arguments, but these arguments are simple but powerful. First of all, we have these 3 arguments. The first 3 arguments, row fields, values, and functions. These are the required arguments that you need to specify at least to get a summary table by using GROUPBY function. And next we have these 5 arguments, the next 5 arguments, which are optional, but still you can use them to expand the functionality of your summary table. We'll understand all these arguments one by one. First of all, we have the row fields argument. Row fields argument is basically the column that you want to use as the row for which column you want to create your summary table. So if you can see in my summary table that I have derived from this main data, I have two row fields. The first is the region and the second is product. And after that, we have values argument. That is basically the column that you want to use for values. And in my case, I have used units sold for values. You can specify more than one column. Let's say if you want to go with units sold and sales amount, you can specify both the columns in the values argument. And after that, we have this argument function. So what happens is once you specify the row fields and values, now you have option to choose a function, a kind of calculation that you want to apply to get the summary table. So in my case, when I have this summary table, I have used the sum. But if you want to use count, or if you want to use average, or want to use some other kind of calculation, so you have a long list from where you can choose. Now after that, moving to our optional arguments, the first one is field headers. So field headers is basically these headers that we have here. So when you select data where you have headings, you can specify, hey, I want to have headings in my summary table as well, or I want to hide them, or I want the function to create these headings for me. This is something that you can do with the field headers argument. After that, we have total depth, and total depth is to control the total that you have in your summary table. So if you want to have your total of, if you want to hide the total, or if you want to have total at the top of the summary table, that's something you can control with the total depth argument. And after that, we have sort order. Now in the sort order, you can specify that which column in the summary table you want to use to sort your data. So let's say if I want to sort my data based on units sold, in that case, I'll specify the column number, the third column number, because I have three columns in my summary table, 1, 2, and 3. And I want to specify 3 because I want to use units sold. And that's something I can do with sort order. And I'll use 1, a positive number or a negative number, to sort data from ascending, from highest to lowest, or from lowest to highest. So if I want to sort my data in ascending order from lowest to highest, I'll use a positive number, and for descending, I'll use a negative number. I'll show you these things in the examples. And after that, I have filter array. The filter array allows you to filter your data based on a condition. So if you want to create a summary table from your main data, but you also want to filter that data before you create the summary table. Let's say in the region column, we have 4 regions: north, south, east, and west. But I want data only for north, south, and east. I don't want data for west. In that case, what I'll do, I'll create a condition to not to include west from the region. And then I'll get that summary table here in the result. So that is something we can create in the filter array argument. And after that, last but not the least, we have field relationship argument. It sounds a little tricky, but it's a very, very useful argument. Now what happens is when you sort your data, let's say if I sort my data based on product, in default way, when I sort my data using the product column, it will first sort it by region and then sort it by product. You can see here, even if I sort by laptop, so I want laptop to be at the top. What it will do, it will sort data by region first, and then it will put laptop at the top, and then phone and tablet. So the point is the product column will always be dependent on the region column while sorting. But in the field relationship argument, we have option to specify if I want to filter my summary table or group table based on the product column, but I don't want that relationship with the region column. So I can change that relationship in the field relationship argument, and then it will sort my table, the summary table, independently based on the product column. So this is something we'll understand in the examples, but these were the arguments that we have in the group by function. Let's start with a simple example. Let me enter the group by function here, and in the rows field, I'm going to go with region. Now you can see here, when I specify this region column, I also selected the row where I have the headings. And now I'm moving to the values and I'm going to select units sold. And then for values, as I told you, we have a list of calculations that we can use. We can use simple calculation like sum, average, median, count A, and we can also go to a custom calculation using lambda function. So if I go with sum and close my function without specifying any other argument, if I hit enter, you can see I get this simple summary table where I have east, north, south, and west, and then I have a total. But right now I don't have headings. So what I'll do, I'll go back and I'll go to field headers argument, and here I have further 4 options. So one is no, which is by default not to show any heading, and then yes, but do not show. So it's asking me, hey, do you have headings in your data that you have specified? And I'm saying yes, but do not show that headings. And then I say no, but generate. I don't have headings in my data, but I want the group by function to generate it for me. And the fourth one that says yes and show, that I have headings in my data that I have specified and I want you to show those headings. So what I'll do, I'll select this option from here and then close my function. And now you can see I have my headings where I have the first row, region, units sold, and then total at the end. Now when I again edit my function and go to total depth argument. Now again, I have further few options. The one is no total, and then having grand total, and then having grand total and subtotal. So if you specify more than one column in the row fields, let's say region and product, in that case, you can also show subtotals with the summary table. We'll see it in just a few seconds. And then we have the fourth option that says grand total, but at the top. And then the fifth one, grand total and subtotals at the top. So you can specify the location of the total as well. So if I go with grand total at the top and hit enter, you can see now I have the heading row, and then instantly I have a total row here, and here is my data below the total. Now if I edit my function again, and instead of having one column in the row fields, I'm going to say I need 2 columns. That's region and product. And my range is changed here from C1 to D51. That means 2 columns. And now when I hit enter, you can see I have data for region and then for product and for units sold. Let me just change my total from top to bottom, and also subtotals with the grand total. And here I have my data, my summary table where I have the heading. That's the heading. And then I have data for East, the region East, and then the products for region East, and then units sold. And then again, total for East, and then same for the North, same for the South, and same for the West. And in the end, I have a grand total. So this is how you can use these 2 arguments, field headers and total depth. You can change the way you want the totals and your headings as well. Now let's create a one more summary table and use the sort order argument. When I enter group by, this time I'm going to select region and product in the rows field, and for values, I'm going to go with units sold and sales amount. So I have 2 values column. So I have 2 columns in the values argument, and then in the function, I'm going to go with, let's say, sum, and hit enter. Here I have my summary table, but let me just add headings and then only the grand total. Now I'm into my sort order argument, and here I can specify the column number that I want to use for sorting. I'm going to go with, let's say, units sold. That means the 3rd column that I have in the summary table, and hit enter. And you can see the data is sorted using the units sold argument, but it is still based on the 1st column, 2nd column, and then the 3rd column. You can see I have data first for East, and then for North, then West, and then for South. And that's how it is sorting the units sold further in the in the region. I have east, and first I have the lowest and then the highest and then the highest. And again, same here, lowest, lowest, and then the highest. And again, same here, lowest, lowest, and the highest. So it's using the region first and then using unit sold to sort the data. As I mentioned in the starting of this video, if I use this column to sort my data, it will still have a relationship with the first column to sort it based on this and then sort it based on this column. And that is something we can use in the field relationship argument to break this relationship. We'll understand it in just a few seconds, but let me just move to the next argument. Let me just edit this function from here. Now, when I move to filter array argument, as I told you that we can filter data for a specific condition by using a specific condition. So let's say if I want to have data only for laptop and tablet, not for the phone, what I'll do, I will select this column here. That's my product column. And here I will create a condition. A condition is not equals to phone. What I'm saying here, I want all the values which are not equals to phone in the product column. When I hit enter now, when I hit enter, you can see my data has tablet and laptop, but there is no phone in the product because my condition is not equals to phone. That means laptop, anything other than phone. And that's how you can filter your data using a condition in the filter array argument. Now let's move to our last argument, that is field relationship argument, which is actually connected with the sort order argument. Let me create a simple summary table. I'll go with region and product for row fields. And this time I'm going to go with sales amount only. And then in the function, I'm going to go with sum. And now yes and show for headings, only grand totals. In sort order, I'm going to say the second column, that means the product column. And now I'm going to close my function. This is my simple summary table where I have region, product, and sales amount. And I'm sorting my data based on the product. Now you can see here, even though I'm sorting the same condition, the same situation, even though I'm sorting based on the product, it is sorting it first for the east and then laptop and phone and tablet, and then again for north, laptop, phone, tablet. Now to break this relationship, what I'll do, I will go to the field relationship argument. And here the first option is hierarchy, follows a hierarchy using the column that I have before the product column. That's the region column. But when I use the table and hit enter, now you can see the actual sorting of the summary table based on the product column. I have laptop first because L, the same A to Z. I have product with the alphabet L, that is laptop. Irrespective what I have in the regions column, I have laptop and then I have phone and then I have tablet. That's how it is sorting data only based on the product column. The relationship that I had before with product to region column is now broken. That's how you can use field relationship argument if you want to sort your data based on a column which is the second or third column in your summary table. Let me start off with the syntax of pivot by function. We have a long list of arguments in the pivot by syntax, but we're going to learn each of these arguments in depth using examples. First of all, I have row fields, column fields, values, and function. And these four arguments, the first four arguments are required that you minimum need to create a pivot table using pivot by function. The whole idea of using pivot by function is to create a pivot table by a function. And the row fields is the field that you need in the rows. In my case, I've used region here, and here I have these rows. east, north, south, and west. That's the row field. And in the same way, you can specify the column fields. And in my case, I have used product as column fields, that is laptop, phone, and tablet. And after that, we have values. That means the column where I have the values that I want to use to summarize this pivot table. I have used units sold, and this is the units sold, the entire pivot table of units sold, region wise, product wise. And after that, we have function, and function is basically a list of functions that you want to perform to create a pivot table. Let's say if you want to have average of region wise, product wise, units sold, in that case you can select average from the function list. And if you want to have sum, then you can select sum. So there is a list of, let me just show you here. When I enter pivot by function, and if I go to function argument, you can see I have this long list of functions that I can perform. These are the 4 arguments, the first 4 arguments which are required, and you need to specify these arguments to have your pivot table. At least you need to specify these 4 arguments to have your pivot table. Now after that, we have field headers. This argument controls if you want to show your headings in the pivot table, or if you don't want to show the headings, or if you want pivot by function to generate headings for you. We'll understand this argument with an example. And after that, we have row total depth and column total depth. Now these 2 arguments helps you to show total row or total column, or even subtotal rows and subtotal columns. We'll understand about it in the example section. And let me move ahead. And now we have these 2 arguments, row sorting order and column sorting order. Now these 2 arguments helps you to define the sorting order. Let's say if you want to sort using the first column, or you want to use the last column, that is the total column, you can specify that in the row sort order, which column you want to use to sort the rows. And in the same way, how you want to sort your columns. You want to use the first row, or you want to use the last row. And after that, we have this argument filter array, which you can use to filter your pivot table. If you want to apply a specific filter, let's say you want to filter your pivot table based on products, in that case you can use filter array argument. We will learn about it in the examples. Let's start with our first example here. I'm going to enter pivot by function, and now in the pivot by, I have first of all the row fields. I'm going to go with region, and moving to column fields, that's call fields, I'm going to go with the product. And after that, the values column, and values column is the sales amount. You can see here I'm also selecting the row for headings, the row where I have headings, so I'm also selecting those rows as well. In my reference, I have the first row as well in the I1, and then J1 and L1. And after that, simply my function, the calculation that I want to perform with the pivot by function, I'm going to go with sum and close my function and hit enter. And you can see here I have my simple pivot table where I have region in the rows and products in the columns, and here I have my all the values, and I also have the total row and the total column as well. This is the simple way of creating your pivot table using pivot by function. Let me just edit it again. Let me just change the alignment to show you the formula. So when I edit it, you can see here this column is the region column that I have used here, and then I have the product column here, that is basically here as columns, and then I have this column, the L column, as values, and then my function, the calculation that I want to perform in the function. Now let's understand the next argument that we have, and that argument is field headers. Now when I go to field headers, as I mentioned, we have 4 options further where I can specify if I want to have headings in my pivot or not. The first option says no, that I don't want to have headings, and then it says the next option, yes but don't show. That means in my data I have headings, but I don't want to show headings in the pivot table. And after that, the third option, it says no but generate. That means I don't have headings in my data, but I want function, pivot by function, to generate headings for me. And then it says yes and show. That means I have headings in my data and I want pivot by function to show those headings. And let's say if I say no but generate the number 2 and close my function, you can see here, this is my heading row that says row field 1 and value 1, and here I have column field 1. So this is something by default option which is there, but in most of the cases, if you don't have headings in your data, it's always better to not to show these default headings and to use hard values as a heading row. So now I'm gonna say yes and show because I have headings in my data. So I'm gonna say yes and show and hit enter, and here you can see it says sales amount, region, and the product. And if I say yes but don't show, so I'll get the same exact pivot that I have got in the last example. So this is the field headers argument that you can use to control the heading row in your pivot table. And now here we have the next argument, that is row total depth. That means how we want to show the total row in the pivot table. So we have 5 options. The one is no total, that I don't want to show any total in my pivot table. And then I want to show grand totals, a row. At the bottom of the pivot table, I want to show the grand total row. And after that, we have grand and subtotal. So if you have multiple row fields, in that case, you can show grand total as well as subtotal. So I'll show you with this example. And then we have grand total at the top. That means when you have grand total, only grand total, instead of showing it downwards at the bottom of the pivot, it will show at the top of the pivot. So this option you have, kind of flexibility that you can change the position of the grand total. And in the same way, in the next option, we have grand total and subtotal at the top. So you can show grand total and subtotals at the top. So let me go option by option and show you how each option works in this argument. So I'm going to go with 0, close my function and hit enter. So you can see here, I don't have any grand total row or subtotal row in my pivot table. Now, let me move to the next option, that is grand total. I'll close the function, hit enter, and you can see I have this grand total row at the bottom. And when I say grand total and subtotal, and now when I hit enter, you can see this is my grand total row. But along with that, because I have region and then I have products, and for each region here I have subtotal for south, for west, for north and east. So these are the 3 options, and after that, starting from the 4th option, we can change the position of the grand total row or this grand total and subtotals row. So I'll say -1, and this time I have grand total row at the top. And in the same way, when I say -2, now I have grand total at the top and then subtotal for the east, subtotal for north, for south and for west. So that's how this argument, this row total depth argument works, where you can specify you want grand total, you want subtotal, and the position of grand totals and the subtotals. Now, just like the row total option, the argument that we have for controlling the total row, just like this, we have an argument that allows us to control the column totals. So I'll skip this row sort order. I'm going to explain this argument in just the next example. But right now, along with the row total depth, I will also explain column total depth. So this is my simple pivot table where I have columns and rows as well. And now I'm gonna edit it, skip the field headers, skip the row total depth, skip the row sort order. And in the column total depth, you can see again I have 5 options which are exactly same like row total depth. So what I'll do, I'll go with grand totals at the top. And now when I hit enter, you can see these are my columns where I have values, and this is my total column, the total column which is at the top. At the top means at the starting, just like when we use rows. Let's say, let me just edit it again and show you this row total. Let me just, I'll say grand total at the top. Now you can see my total row is at the top and my total column is also at the top. That means at the very beginning of the data, at very beginning of the pivot table, not after the columns, but before the columns. So that's how you can control everything, every kind of total that you have, grand totals or subtotals for columns as well as for rows. But you have 2 different arguments to control. You have further 5 options you can control as per the pivot table you have. We have 2 different sorting arguments. One is to sort row fields and second is to sort column fields. Now here I have this simple pivot table where I have region for row fields and then I have units sold as value. Now when I edit my pivot by function here and then go to the row sort order, you can see this argument is an optional argument. Even if I don't specify anything, there is some default value that pivot by function uses to sort the pivot. So if I don't specify anything, you can see it is using the first column for sorting the rows and it is using ascending order. So I have east, north, south and west. And the default value here is 1. Even if I specify 1 and hit enter, you can see there is no change because this is the default value. And let me just mention again, it is using the first column and ascending order to sort. But if I want to sort by descending order, so now what I need to do, I need to use -1. So positive number for ascending order A to Z and negative number for descending order Z to A. Now when I hit enter, you can see now I have west, south, north and east. Completely opposite. But now if I want to change the column, let's say instead of using region, I want to use units sold. So what I'll do, I'll go back and I will specify 2. That's the second column number. And now when I hit enter, you can see I have my pivot sorted using units sold, but in ascending order, 49, 64, 64, and then 72. And if I go back again and use -2, this time 72, 64, 64, and 49. So this is the highest to lowest. Now let's move to our second argument, that is column sort order. Now when I say column sort order, in this argument, I need to specify the row number that I want to use to sort the columns. But here you need to understand one more thing. I have this pivot table here, which has almost 4 regions and 1 total row and 1 heading row. But when I sort this pivot table, I can only use the first row and the last row. I cannot use data which is in between. So if you say I want to sort this pivot based on the values that I have in the east region, I cannot do that. I can use the first row and I can use the last row. That's the total row. So when I edit my function again and move to column sort order and I say I want to use the first row, that's the heading row, in descending order. So I'm going to say -1 and hit enter. And now you can see I have tablet, phone, laptop, because I cannot sort total because that's the last column here. That's the last column where I have total. So I cannot sort that column. Only these 3 columns will be sorted. And if I go back again, this time say 1, that's a positive, by default number, now I have laptop, phone and tablet. So that's how the columns are now being sorted. But if I go and say -2, because this time I am referring to the total row that is at the bottom. When I say -2, hit enter, you can see now I have this, all the columns of the pivot sorted based on highest to lowest using total row 89, 87 and 73. Now you can use row sorting order and column sorting order at the same time. You can see in my pivot. Now what happens is, let me just illustrate it for you. When I'm using row sorting order and column sorting order, in the row sorting order I can use this column, this is my first column, and I can use this column. Let me just mark it for you. And for the column sorting order I can use this row and this row. That means I have two columns to sort my pivot table in rows and two rows to sort my pivot table in columns. But if I specify, let's say if I go here and specify 3, I try to specify 3 and hit enter, I will instantly get the value error because I only have two columns and two rows that I can use to sort my pivot table. And now let's understand the filter array argument. Now with the filter array argument in PIVOTBY function, you can apply a filter to your pivot table. Now you can see here I have this small pivot table that I have got from PIVOTBY function where I have region and I have units sold. And above I have this small drop down where I have name of all the products. I have laptop, tablet and phone. Now what I'll do, I'll apply a filter to this pivot table that I can control with this drop down list. So I'll edit my function and I'll straight away go to the filter array. Now here, first of all, I need to specify the column where I have the filter values, the column that I want to use to filter the data. And along with this, I'm going to say equals and tablet. And now I'm going to close this function and hit enter, and you'll see my filter, my pivot will instantly filtered with the tablet product. Let me hit enter. Now you can see the total is now changed. I have 89 units. Let me just filter it from the data just to verify. And let me just see the total. You can see we have total 89 units sold for tablet. And now just by changing the product name from this drop down, I can control the filter for my pivot table. So that's how you can use the filter array argument to filter your pivot table the way you want. Now let's understand the concept of the last argument that we have, and that's relative to. Now what happens is, in a simple pivot table, when you create a simple pivot table using PIVOTBY function, just like I have here where I'm using the product, and then here I'm using in the rows field, I'm using region, and here I have my units sold, and I have a total column and then a total row. Now what is happening here, let me just show you a simple example. When I say laptop for East, I have this value here that is 18. That means the total 18 units for the laptop for the East region. Now here I'm using the sum function. Let me just edit here and show you that I'm using the sum function. And when I'm using sum function, this value 18 is completely independent. It doesn't have to, to work with any other value. 18 is exactly there in the data. And the same thing, 21 units for North, and then 20 for South, and then for West. But now when I edit my function again and go to the function that is %of, now when I hit enter, you can see I get these percentages. Let me just apply the percentage. Now here I have 25%, but now this 25%, to calculate this 25% of laptop for East, I need to have a subset value that needs to be the total, and that's how I get 25% of something. you see here, I have 25%, 29%, 27%, and then I have 19%, which is the total of the laptop sale. And that is why I have 25% of 100%, because when I'm calculating 25% here for East and laptop, I need a total value to calculate that 25%. So there is a different value, a different total that I needs to have to calculate this 25%. That means this value, this 25%, the value 25% is dependent on a sort of total, and that's how I calculate this 25%. Now, with the help of relative to argument, let me just go to the relative to argument here. Now we get the option to decide which total we want to use. By default, I'm using the total of the column. That is why I have 100% here, and the 25% is this value. The East for the laptop is 25% of the total laptop, because East is contributing 25%, 29, 27, and this is the exact percentage in the column, and 100% for the entire laptop column. But if I want to change it from this column total to row total, this is where the use of relative to starts. So when I go back to my relative to argument, you can see here I have column totals, that's by default. But when I change it from column total to row totals, hit enter, now I have the total for the row, and that's for the East. Now it says that laptop contributes 37% in the East region, and in the same way phone contributes against 37% and tablet contributes 27%, and that's how I have the 100% for the East region. But now these percentages are not based on the column but based on the row. So from product to region. And in the same way, if I go back and change this setting from here again, let's say if I say I want grand total. So now it's neither based on the region nor on the product. It's basically for the entire total, entire units of the sales we have. Each percentage is based on the entire total. So I have 7% from the total 100% for East and laptop, and that's how when I total this part, you can see I have 100%. And now let's change the structure of the pivot and see how this relative to argument works when I have multiple row fields. So when I go and change it from K column and include L as well, and I remove this from here and hit enter, now you can see I have this pivot table here. Let me just add headings as well. So the field headers are yes and show, and hit enter. Now I have a pivot table. Let me just change the alignment a little bit and apply percentage to all. And the same thing, all the percentages is basically the portion of the grand total. And if I go back again and try to add row subtotal as well, subtotals and grand total, now this time I need to again apply the percentage, and you can see here I have this percentage here, which is 775 and then 20, and all these percentages that I have in between are the part of the 100% here. Now let's say if I want to change it to parent row total and hit enter, now you can see first of all I have percentage, which is basically the total of 20%. So within 20%, which is basically the part of the main 100%, I have these percentages 37, 37, 27, that makes 100% of 20%, and then 20% is the 20% of 100% from here. So this is the total of this, and this 20% is the part of this 100%. So that's how I can change the way I want to calculate the percentage when I'm using %of function. This is the point where I need to use the relative to argument. And just like the %2 function, you can also use the relative to argument when you are using a custom calculation in PIVOTBY function. Alright, so now let me start with the syntax of lambda function. In the lambda function, there are two major things that you have in the syntax, two major arguments. The first is parameter and the second is calculation. Now the parameter is like a name that you specify and then store a value in that name. And calculation is the actual calculation that you want to perform with lambda. Now in the syntax, we have parameter 1 and then we have parameter 2, and this way you can specify more parameters. If you want to store more values, if you want to specify more values for the calculation, you can create more parameters. And once you are finished with those parameters, you need to specify the calculation that you want to perform. But how we specify these parameters and the calculation, let me explain it to you. In this generic formula that I have here, the lambda function, you can see first I have the quantity, and quantity is my first parameter. It's like a name where I will store the quantity. And after that, I have second parameter, that's price. And here in this parameter, I will store the price. Once I'm done with my parameters, I have quantity and price. If I don't want to specify more parameters, the next thing is to specify the calculation. And the calculation is quantity into price. I have quantity here, I have price here, and here I have the calculation by using these two parameters. After that, the next thing is to specify the values that I want to store in the quantity and in the price, and then lambda will use those values to perform the calculation. I'll close my lambda function here. You can see I have the closing bracket, and then I have one more bracket here. That's a starting bracket, and I'm saying the first cell reference is B2, and B2 have the value for the quantity. And then I have one more cell reference that says B3, and B3 has the value for the price. Now, if you see the positioning of these two references, B2 and B3, and positioning of these two parameters, the first parameter is quantity, and that's why the first cell reference, the value that I have in the first cell reference will go to the quantity. And after that, I have B3, and the second parameter is price, and that's why value from the cell B3 will go to the parameter price. Now I have my values, and after that, what lambda will do, it will use value I have in the quantity here in the calculation, and this value of the price here in the calculation, and in the end I will get the final result of multiplying quantity into price using these two values that I have specified from cell B2 and B3. I'll use the same example in just a few seconds, but let me explain it to you, a few points that you need to know before naming your parameters. And here we have these points. The first is the length of the name of the parameter. The length, you can use 1 to 255 characters, but it's always better to have, between 3 to 20 to make it more readable and understandable. And after that, you need to start your name with a letter or underscore. And the third one is you cannot use a space or special symbols within the name, and you need to avoid the cell references. You cannot name a parameter as a cell reference because lambda will treat it as a cell reference, not as a name. And the last point is there are a few words, especially the names of the functions, that are reserved. So you cannot use those names as parameter. These are the few points that you need to note down to use lambda function. Now here I have the same data, same quantity and price. Let's write the same lambda function. I'm going to enter lambda here, and the first parameter is quantity. You can use any kind of name for the parameter as long as that name is understandable. I'll say QTY for quantity and price for the price that I have. Now I have two parameters here. Let's start with the calculation. The calculation is quite simple. I'm going to say QTY into price and close my lambda. And now the next thing is to specify the cell references where I have the actual values. I'll start one more bracket. I'll say B2 and the second cell reference is B3. Close this bracket and hit enter. And you can see I have 4,000 in reserve. That's the total amount by multiplying quantity into price. Now I'll show you the real deal with the lambda function. The whole idea of using lambda function, as I said, is to create custom calculations and custom functions. Now let's say I have this data here where I have name, base salary, bonus rate, and sales amount, and to calculate the final pay, I need to get a kind of a bonus for the employee by using bonus rate and sales amount. So that means multiplying the bonus rate with the sales amount and then adding that bonus to the base salary. If I write a lambda function, or if I write a normal function here, or if I write a normal formula, so it will go something like this: base salary plus the bonus rate multiplying with the sales amount, close my bracket and hit enter, and here I have the final pay. But I can use lambda to create a actual custom function that will work exactly like this. First of all, let me add a lambda function here and say my first parameter. I'm going to use same names, base salary. Then the second one is bonus rate. The third parameter is sales amount. And now the calculation. The calculation is base salary plus, I'm going to use a bracket for bonus rate and sales amount. Even if I don't use it, the calculation will still calculate the right amount. I'm going to say bonus rate into sales amount, close my bracket and close the lambda function here. Here's the best part. I will not specify anything here, but I'll just copy this from here and go to my formulas and then define names and name manager. Now here, I'm going to click on new, and here I'm going to give this function a name. I will say get salary, and here I'll remove everything that I have in the refers to and paste my lambda calculation and workbook as scope and click OK, close, and here I am back in my worksheet. And now this is where the magic happens. When I say get salary, you can see I have this custom function here, and when I insert this function, you can see I have 3 arguments here: base salary, bonus rate, sales amount, and these arguments is basically my parameters that I have specified in my lambda calculation. Now I'm going to say this is my base salary, this is my bonus rate, this is my sales amount, close the function, hit enter, and here I have my final pay. How cool is that? Now I will go one step further. Now if you see, let me just show you a different function. Let's say if I enter lambda function here again, you can see with each function that we insert in Excel, we get this small tooltip here that describe the function in just a few words. And I want this tooltip, this description for my custom function. Now what I'm going to do, I'm going to delete it and then go back to my formulas, define names, name manager, edit the get salary, and here in the comment, I'm going to add a description that I already have that says return total pay by adding the base salary to the commission calculated as bonus rate into sales amount. Click OK and close, back into the worksheet, And when I enter get salary, you can see I have this tooltip here. Here I will complete my function here. This is the base salary. And this is my bonus rate. This is the sales amount. Close the function, hit enter, and here I have my value. All right, so now let me start off with the syntax of map function. Now in the map function, as I said, the whole idea is to apply a custom lambda to an entire array and get an array of results. The first argument that we have is array. That's obviously the original array that we want to use for applying lambda function. And after that, we need to specify the lambda function itself that we want to use for the calculation. But if you have more arrays to define, let's say you have 2 or 3 arrays to define, in that case, you can specify your second array after the first array and then your third array. And then after that, you can specify your lambda function. Map function has ability to handle total 254 arrays and calculations in lambda. Total argument capacity is 254. Now let me show you a simple way why we are using map function. You can see here, this is the array that I have here. And here I have this result array where I'm getting a result for each value from the array where I'm multiplying 2 with 2. For the first value, I have 4. And then for the second value, I have 8. And for the third value, I have 12. That's how my map function is working, by applying multiplication to each value in the array. Let me take you to this data and let me write this formula for you. When I enter map function, first it asks me for the array. So here's my array where I have numbers 2, 4, 6, 8, 10, 12, and 14. Now after that, either I can specify the next array or I can specify the lambda function for the calculation. I'm going to go with lambda and I'm going to say my parameter. The name of the parameter is my num. And after that, I'm going to say my num into 2, or even I can say into 5. And I'm going to close my function, lambda function and map function, and hit enter. And here I have my result array with each value from the original array multiplying with the 5. And that's how I have this result array here with 10, 20, 30, 40, so on and so forth. Now, the same thing I can do with a different calculation. Let's say if I want to divide it with 2. Let's say if I divide it with 2, my num divided by 2, and hit enter. And now this time I have this array where I have division of each number from the original array by 2. This is a very basic way of understanding map function with a very basic calculation. But let me tell you a point here. I'm using map function to apply a calculation to each value in the array. But this thing I can do without using map function. Let's say if I select this array, because I have dynamic arrays in my Excel, and if I specify an array instead of a single cell, I can apply a calculation, and that calculation, the result of that calculation will spill over and I'll get an array of results. If I divide it with 2 and hit enter, you can see I get the result array exactly same without using map function. Then why I need to use map function? Well, to answer this question, I have a different example for you where we need to use map function, where map function will help us to get an array of results. Let me move to the second example. Now here you can see I have this small data with 2 columns. In the one column I have letters and in the second column I have numbers. Now my whole idea is to count the rows where I have A in the letters column and 3 in the numbers column. Even if I just look manually, I can count it. There are 3 rows that I have in the data. But what if I want to count it using a formula? So if I use the AND function and select my first array and say I want to count cells with the value A, and the second condition is to count the cells with the value 3. Now in this case, when I hit enter, I don't get an array of results. So this is the situation where I can use the map function. Let me delete it here, enter map function, and I'm going to say this is my array, first array, and this is my second array. And now I'm going to start with my lambda, and I'm going to say L and N for numbers, and I'm going to enter AND function where I'm going to test two conditions. And now I'm going to say L equals to A and N equals to 3 and close AND function, close lambda, close map function, and hit enter. Now you can see I get this array where I have false and true only for the rows where I have A and 3, both conditions are true. Now to get a count, I'll go back, convert this false and true into 0 and 1, and then simply I'm going to say sum and close my function. And here I have count of the rows where I have A and 3, both conditions are in the same row. And even if I change it from here, let's say if I change it here, A and 3, I'll get the count of the rows that I want. Now here's one more example where we can use map function to count cells where we have numeric values. I'm going to say map and then my array, and then I'm going to say lambda and that's my parameter my num. Let me just enter the capital N, and now I'm going to say is number to test the value is number or not. My num, close is number, close lambda, close map, and hit enter. And now again I have this array for true and false. That's basically true for numbers and false for text values. Again I'm going to say double minus sign and wrap it with the sum function to get the count in return. Alright, so let me start off with the syntax of BYROW and BYCOL functions. Now, as I said, the whole idea of using BYROW and BYCOL function is to specify an array and then get the result for all the rows or all the columns in one go. You can see here, I have this column of total column for all the rows with a single formula, and the same goes with the BYCOL function. When I get this entire row, the total row for all the columns using a single formula. Now, when I move to the syntax of BYROW and BYCOL functions, we have identical arguments. The first is array. The array is the main source data that you have and that you want to use in your function. In my case, this data that is product-wise and month-wise data is my array that I'm going to define in my BYROW or BYCOL function. Now, after that, we have this argument, which is an optional argument, function. Now, when you move to the function argument, you get this list of calculations that you can use. Now, the whole idea of using BYROW and BYCOL functions is to use it with lambda function to create a custom calculation, and then we'll apply that custom calculation to each row one by one and give you an array of results. That's the whole idea. Now, let me move to my first example here. We're going to use the same data that I have just showed you, and let me just enter BYROW function. Now, in the BYROW function, you can see I have this array argument, and I'm going to specify my array here that is from B2 to M11. Now, when I specify array and then go to the function argument, you can see I get this list of functions that I already have. And in the end, I have the lambda function if I want to use the lambda function. But now I'm going to go with a simple sum and I'm going to close my function. Here I have my range, the array. And here I have my calculation that is a sum. I'm going to hit enter to close my function and see what I'm going to get in return. And you can see the moment I hit enter, I get this column for total for all the rows one by one. But I get this using a single function BYROW. And the same thing goes with the BYCOL function. When I enter it, select my array here, go with the sum and hit enter. And again, I get a row, total row for all the columns just using a single function, BYCOL. Now let's say if you don't want to use the sum function, but you want to actual lambda function, let me enter the BYROW function here and specify my array that is the same B1, B2 to M11. And then I'm going to go with lambda here. And in the lambda, I'm going to say my sales, that's my parameter. And then I'm going to say sum my sales. Close the sum function, close the lambda, close the BYROW, and hit enter. And again, I get the same total column for all the rows. And the same thing goes with BYCOL function. When I enter BYCOL, select my array here, and then say I'm going to go with lambda, specify my sales, and I'm going to say sum my sales, close sum function, close lambda, close BYCOL, and hit enter. And here I have a total row for all the columns. Now in this example, I'm going to identify for each row that how many months we have where we have sale above 40 or equals to 40. Now, if you can see in the smartphone, we have 3 months, March, April, and May, where we have sales 40 or above 40. If I select this range here, let me just do it manually first using a dynamic formula and try to write a condition that says greater than 40 or equals to 40. That means greater than, equals, and then 40. Now when I hit enter, you can see here I have this entire array of result where I have false and true based on the condition. And in the first row, which is for the smartphone, I have 3 cells where I have true. That means there are 3 cells where I have sales above 40 or equals to 40. Now if I use, let's say, double minus sign, let me just wrap it in brackets and then use double minus sign and hit enter, you can see now I get the 0 and 1 for false and true. And when I use the sum function, let's say sum, and I'm going to say, and now when I hit enter, I get 33 for all the products, for all the months where I have sales above 40 or equals to 40. But my requirement here is to get this result independently for each of the product. And for this, I'm going to use the BYROW and lambda function. I'll copy this calculation from here that I have already written, and let me just copy it again, and let me enter BYROW function here. I'm going to go with BYROW and then say this is my array, and after that I'm going to say lambda and my parameter, that's my sales, and here I'm going to enter my calculation, the custom calculation. And now instead of using this range, I'm going to use my parameter, that is my sales, and I'm going to close BYROW function here and hit enter. And if the same thing that you want to do with columns, let's say, let me just copy it from here. Let's say if I want to identify that how many products I have in each month where I have sales above 40, I can use BYCOL function. I'll go with BYCOL, and because all the arguments in BYCOL and BYROW functions are identical, I don't need to change anything. I'll just hit enter to get my result row. And you can see here I have a row with the count for each month where the sales is above 40 or equals to 40. In the first month, that is January, I have 49, and then I have 46, 2 products, and then I have 48, 41, and 40 here, and that's why I have 3 here. And now in this example, let me show you a very interesting thing about BYROW and BYCOL functions. It's like a limitation, but it's also something that you need to understand before using these 2 functions. Now, when I use this function, which is a different function, the large function, this function allows me to get a highest or multiple highest values from an array. When I select this array and then specify curly brackets, and within the curly brackets, when I specify value 1, 2, 3, now this way I'm saying this function to give me top 3 values from this array. And if I just go to 1 and 2, then I get the top 2, the highest 2 values from the array. Now, when I use this calculation, let me just enter the BYROW function here and select the entire array here. And in the calculation, when I say lambda and then enter my parameter, that's my sales, and then in the calculation, when I enter the large function, and let me change this range with the parameter name, my sales, and close the lambda, close the BYROW. And when I hit enter, now when I hit enter, I get a calculation error. Now this error is because, let me just change this value from here. Let me show you. Let me hit enter. Now, when I say 1, when I enter the 1 for getting the first highest value, I get the entire column with the first highest value for each of the product. But when I go back and say, now give me 2 values, the first and the second, I get calculation error. Now, this problem is because BYROW function can give you multiple values for an array, but it cannot give you multiple values for a single row in the array. You can get multiple values for the entire array, but you cannot get 2 values and have 2 columns here by using a custom calculation. This is one kind of a limitation that you have while using BYROW function, but that's not actually a limitation, but this is something, a kind of situation we have, that we cannot use BYROW because that's not the actual usability of the BYROW function. There is one more thing to BYROW and BYCOL functions, and this is exactly opposite to what I have just told you. Let me just delete it and let me enter BYROW function here and let me select the array. Now, when I move to my function argument, you can see I have this list of all the calculations that are available. Now, let's say if I want to have multiple results, let's say if I want to have multiple functions that I want to use and want to get multiple values here, let's say sum, average, and count A. For this, I can use this function called hstack. And within the hstack, I'm going to say sum, I want average, and then I want count A. I'm going to close hstack, close my BYROW and hit enter. And here I have the total, that is 350. You can see I have 350 sum here, and then the average is also correct, 29.16, and then I have the count of all the values here. Now, this is exactly opposite that I have just told you a few minutes back. Instead of having a single value for a row, we have multiple values. But now you can see, instead of having an entire column of these values, these calculations and these results, we have the result only for a single row, even though in the function we have specified the entire array. This is something that is quite interesting while using BYROW function, but the whole idea of using BYROW function is to get result for an entire array in the form of a column where we have multiple results for each of the row. And the same thing goes with the BYCOLUMN, where you have an array and you have a row of results for each of the columns. Before we start learning about reduce function, let me remind you, in the last video, we had just learned about the scan function. The entire working of both the functions are exactly same, but the way of returning a result is different. It takes a list of arrays that you specify, and then it performs a custom calculation that you specify using lambda function. It performs that custom calculation to each value of the array. In my case, I have these values, so it will start from the first and then go up to the last one, performing that custom calculation. Now, while performing this custom calculation, what it will do, it will take result from each step and carry forward it to the next, like this, like this, like this, and then up to the last. And that's the same thing that scan function does. But the difference is here. The difference is scan function gives us a result for the each step. It gives us an array of results where we have exactly same number of results as we have number of values in the array. But in the reduce function, when we use reduce function, we only get the final result in the end. If I'm performing an addition, I will result in the end. And just like scan function, we have same syntax here, where we have initial value, we have an array, and then we have the function. Array is basically the list of values that you want to specify. And function is our custom lambda function, which is again like scan function. The lambda function that we have in reduce function has a specific format that you need to follow. So you have, and then you have value. So accumulator is the result from the previous step, and value is the current value of the step. And then you specify the calculation that you want to perform with these two values, accumulator and the value. Now, let me remind you again, in the scan function, we have learned that the first calculation in the reduce function is different from the rest of the calculations. What happens is we have this argument here, initial value, that we have already learned in the scan function. This initial value will be used in the first step of the calculation. And if I, let's say, if I take this different example here, where I have, a list of names, and when I use the reduce function to concatenate or join these names, I get this final result here, where I have each name one by one. It takes the first, then takes the second name, third, fourth, up to the last, and gives me the final result in the end using the custom calculation. Now let's take an example to understand how reduce function works. Here I have this list of values where I have numbers and text as well. But I want to have all these text like A, B, C in a single cell. I want to join them in a single cell, but I also want to have this condition where I will only pick the text values. So I'm going to use the reduce function here because I'm working with text values. So I'm going to say initial value. After that, my array. And now I need to specify my custom calculation. I'll start with lambda. And in the lambda, again, the first thing is to specify the accumulator. I'm going to say my first parameter is accumulator, AC, and then the value. I'll say VA or VL. I'll go with VA. Or I can also use CV just for the, the understanding of the current value. And after that, I'll use if function. And in the if function, within the if function, I'll use is text function. This is an information function that allows me to verify if the value that I have in the current value is a text or not. I'm going to say CV. That means the current value. If the is text function returns true, then by using the if function that I have, before the is text, I want to join accumulator and the current value. Current value is the current value, the actual current value that we have on a step, and accumulator is the result from the previous value. But because I'm using a condition here, it will only take that value. It will only take that value if that value is a text. It will go to each step one by one, but it will take that value. It will consider that step or steps value only if that value is a text. Because my condition is here, the function that I'm using is text that returns true only if the text value is there. And the if function will consider true and then move to the value if true argument. If current value is not the text, then ignore the current value. I'll use AC in that case. That means the accumulator previous steps result, but not the current value. And now I'm going to close the if function. And now I'm going to close the lambda and reduce function. And now I'm going to hit enter and see what I'm going to get in return from the reduce function. This is the A, B, C. That's the second, fourth, and sixth value in the result. Now let's take the same example that we have used in the scan function video. We are going to get the total of decimals. And now instead of using scan function, we're going to go with the reduce function. So what I'll do, I'll enter reduce here. And the initial value is again 0 because I'm working with numeric values here. So I'm going to go with 0 as initial value. And in the array is my average sales price range. And then in the function, now I need to write a custom function. The custom function will start with lambda, again AC and CV accumulator, and now my actual calculation will be AC, that's the accumulator. The value from the previous result accumulator is the previous result's value. And here my actual calculation starts. So AC, as you know, is the result from the previous step. AC plus CV, current value, but minus the integer part. I'm going to use int CV. The int will get the integer part from the current value, and then from the actual current value, I'm going to deduct the integer, and what I will get in return is the decimal part. And then with the decimal part, we'll have this loop of step by step where we will total of decimals. I'm going to close this, close the lambda, and hit enter. And here I have my total of decimals from this average sales price, list of average sales price. The whole idea of using scan function is to specify an array, perform calculation with each value of the array, and then get an array in result where each result has the result of previous step. Now let me explain it to you with a simple example. Here I have a list of names. This is my original array. And my calculation is to join names from the each step. In the first step, and this is my result array, and that's what I have got from the scan function. And in the first result, you can see I have the single name James, which is the first value in the original array. But as soon as I move to the second result, I have result from the previous step and current value. And now when I move to third result, I have result from the second step and third current value. And then again, result from the third step and fourth current value. And that's how it is getting step by step and giving me result where I have result from the previous step and then the current value. And that's how I'm getting an array of results where each result uses the result from the previous step. And this was a kind of concatenation of values, text values. But when we move to numeric values, let's say I have sales quantity here, 100, 120, 130, 110, 140. And when I use the scan function to have a running total, I have 100 and then I have 220. That means 100 from here and 120 from here. So this is the result of previous step and this is the current value. And that is why I have 220. Now further I have 350. That means 220 from here, second step, result of second step, and current value from the same step, from the third step. And then further 460, that means 350 from the previous step and 110 from the current step. And that's how I'm getting this entire running total. And now let's move to the syntax. Now in the scan functions syntax, first of all, we have initial value. I'll tell you about initial value, but let me move to the second argument first. The second argument is the array. Here the array is the original array. In this example, the sales quantity is my original array, and that's I'm going to specify in the array argument. And in this example where I have names, this is the original array that I'm going to specify in the array argument. And after that, I have lambda. So that's the lambda custom calculation that I'm going to use to get the result array. In this example, I was using a concatenation that says the previous value and the current value. And in this example, I was using addition, the result from the previous step plus the current value, 100 plus 120. So that was my calculation, and that calculation goes into the lambda argument using the lambda function. Now let's come back to the initial value argument, which is the first argument, but let me explain it to you now. Now here you can see I was trying to concatenate or trying to put all these names one by one, step by step. The concatenation actually starts from the second step. In the first step, I don't have any previous value because in the step 2, I have value from the first step, the result from the first step, and then I have the current value that I get in the result here in the step 2. But in the first step, I don't have any previous value. I have the current value that is from the first step itself, but I don't have any previous value to use. In that case, I can use the initial value. If I specify, let's say, my own name, let me say, if I enter my own name here in the initial value, in that case, I'll get this name here, my own name. Let me just type it for you. It will be something like this, and then I'll get James. So here, oops, and James. That means James is the current value of the first step, and this, which is my own name, is the initial value. In most of the cases, when we are working with text values, instead of specifying any value, we use a blank value so it won't affect anything in the result. And when we have numbers, in that case, we can use 0 as initial number, because when we use 0, it will not affect anything in the entire calculation array. And there's one more point that you need to understand while using scan function. And that point is, in the scan function, when we use lambda, lambda has a specific structure that we need to follow within the scan function. And this is the structure where we are saying we have accumulator and then we have value. Now here, this accumulator is the result from the previous step, and value is the current step's value. If I go back to my example, when I move to the second step, here James is my accumulator, and the current value, that is Mary, is my value, that is the current value. And when you specify any calculation, let's say if I'm trying to concatenate A and V, that means accumulator and value, my calculation will go here in the third argument within the lambda function. So we'll understand how to use this lambda within scan in just a few seconds. And here I have my first example, and here we're going to use scan function to create a running total. So first of all, I'm going to say scan. Now the first argument is the initial value, and here we have the numeric values, the sales quantity, and that's why I'm going to use 0 here. My initial value is 0. I don't want to use any other number, because if I use, it will make an impact in the entire result array. And I'm going to show you this impact as well after this example. And then I'm going to specify my array, which is the sales quantity. I'm going to go back, and now my function, the lambda function, starts from here. I'm going to say lambda AC. You can use any parameter, but I'm using the exact same parameter AC or ACC or VAL so that we can understand it easily. So I'll say ACC and VAL. ACC is accumulator and VAL is the current value. Now here I need to use the calculation that I want to perform with the original array. So I'm going to say ACC plus VAL. I'm going to close lambda, and now I'm going to close scan. And now when I hit enter, you can see I get this running total. Now to show you how initial value make an impact in the final result array, you can see the first value I have here is 100, which is exactly the first value I have in my original array. But when I edit my function back and add 50 here in the initial value, and now when I hit enter, you can see my first value is now 150. It's not just the first value, all the values that I have here are now increased with 50 because 50 has been added to the initial value and at the very beginning of the calculation. And now the each value in the result array is now increased with 50. And if I go back and remove it, let's say if I say 0, you can see the last number here, the last value here. And when I hit enter, you can see now it's 1860. And now in this example, we are going to use the same data that we had at the very beginning of this video. I'm going to say scan and initial value, because I'm dealing with text values, I'm going to say blank, and then the array where I have names and then the function. So I'm going to start with lambda, and in the parameter, I'm going to say accumulator ACC VAL, and here goes my actual calculation. So I'll say ACC and VAL. Now I'm going to close my function, lambda function and scan function, and hit enter. So here you can see I have all the names concatenating step by step. At every step, we have all the previous names. Here we have James and Mary, and then we have James, Mary, and John. Now here, let me show you the effect of initial value. If I go back and change or add any value, let's say if I add my own name, and here I have double quotation marks, and now when I hit enter, you can see I will have my name with the each value in the array. And this is what we have got in result. Now let me show you a solution to real life problem that we can solve with the scan function. Now here I have days, and then I have average sales price. Now from this average sales price, I want to have a running total, but I want to have this running total only for the decimal part of the price. Let's say in the first price, I have 0.74, and then I have 0.47, 0.77. I want to have a running total only for these decimal parts. So what I'm going to do is I'm going to use scan function, and in the initial value, I'm going to say 0. And in the array, I'm going to specify my column. And now in the calculation again, lambda that says ACC VAL. And now I need to specify the calculation that I want to perform. So it will go ACC plus VAL, which is the current value, minus INT. INT is a function that allows me to remove decimal parts from a number and give me only the integer. So I'm going to say VAL, and now I'm going to close the lambda and my scan and hit enter. And here you can see I have a running total for only the decimal part of each of the value from the array. Now let me show you how this small function actually works. So what happens is, first of all, I'm saying take the current value and then use INT and convert the current value into an integer. So when I minus, let's say I have 11.74 here, and by using INT, I get 11 here. And when I minus the original value with the value that I get from INT, I only left with the decimal part, and that is something happening in my calculation. You can see here the current value minus INT and current value VAL. And after that, I am adding it to the previous result of the step. And that's how I'm getting this running total with the decimal part of the sales price. Right, so let me start off with the syntax of image function. Now, as I said, the whole idea of using image function is to get an image from a URL from internet and then show it within a cell. In the syntax of image function, first of all, we have source argument where we need to specify that particular address or URL of the image. And after that, we have the alt text argument. That means the alternate text. Once you get the source from where you want to get the image, you can specify an alternate text that defines the image. Let's say if I'm using my logo, in that case, I can say, hey, this is my logo, and I'll enter Excel champs logo for alternate text. After that, we have sizing. In the sizing argument, we have 4 further options that we can use. The first is fit to cell. If you want to fit your image within the cell like this, and then we have fill cell. With the fill cell, it will fill the entire cell and it will change the height and width of the image using the height and width of the cell. If you make your cell more wide, it will fill the entire cell and change its width and height based on the cell. After that, we have original size. That's exactly the same size of the image from the source. And after that, we have custom size. When you specify custom size, you specify this in the sizing argument. In that case, you need to specify the height and width for the size, because I'm saying, hey, I want a custom size, and now I need to specify the height that I want to use and the width that I want to use. When you use a source in the source argument, image function supports a list of formats for the image, and your image needs to be of these formats. Like we have PNG, we have JPEG, and we have GIF, and all other formats that is supported by the image function. Now there's one more point that you need to understand, and that's image function. When you specify a source which is on the internet, on a website or anywhere, it gets that image for you and show it in a cell. But to get that image function needs a working internet connection, and that's when it will get that image, it will source that image for you. Now here we have the same URL that is from my own blog, and when I enter the image function here and specify it as a source, and I don't specify anything, any other argument, and just hit enter, I get the image from the source as it is. Now when I move to the alt text, I can specify a text here that says Excel champs logo. Now the benefit of using alt text is if somehow that image is not there on the source, or it is deleted, or if my internet connection is not working, in that case this alt text will help me to identify what this image is all about. Now I'm moving to size, where I have these 4 options: fit cell, fill cell, original size, and custom size. When I go with fit cell, close my function, it shows that image that fits into the cell. It's not using the height and width of the cell, but it actually showing that image in a correct dimension using the height. It's not actually changing the ratio of the size of the image. But when I go to fill cell, that means I wanted to fill the entire cell. This is a different option. When I hit enter, now this time the entire ratio of height and width of the image, the original ratio, is now ignored and the cell is filled with the image. And when I go to original size and close my function and hit enter, and this time you can see the clarity of the image, that logo is now improved because I have the original size of the image. And this way, when I go to the 4th option, that is custom size, in this case, if I don't specify the height and width in the function, I get a value error. That's why I need to specify height and width along with the option that I'm choosing from the sizing argument. I'll say 50 for the height and 250 for the width. And now I'm going to close my function and hit enter, and here I have my image with the custom size. That's how you can use image function to get an image from a source from the internet. Let me start with the syntax of stock history function. Now in the stock history function, we have first two arguments required, stock and start date. In the stock argument, you need to specify the symbol or ticker to extract the stock data. Every company which is listed on a particular stock exchange has a symbol that you need to use in this argument to extract the stock data. If I go with, let's say, Microsoft, I have this symbol MSFT, and I need to specify the symbol in the stock argument. And after that, in the start date, I need to specify the date, a particular date for which I want to extract the stock price. When I specify 1st of August 2025, in the result, I get this small table where I have only two entries. The first entry is the headings, and after that I have the date, the start date that I have specified, and then I have this closing value of the stock for that particular date. This is how the function stock history works when you use only stock and start date arguments. After that, we have 4 more optional arguments. And the third argument is end date. Now, let's say if you want to have stock data for multiple days, let's say starting from 1st August, which is the start date, to 10th of August. Now, when you use stock, the symbol, start date, and then the end date, you will get where again you have a column for dates, and then you have a column for closing stock price for each of the dates. For 1st August to 10th of August, I have these 6 days data, dates and closing price. Now in the fourth argument, that is interval, you can specify the interval of the data you want. Let's suppose if you have a long list of dates, let's say for 2 years, and instead of having daily data, you want monthly data. You can see here I have used this date 1st August 2024 to 31st of August 2025. That means 13 months. And instead of having data daily, I have choose to show or get the monthly data. And that's why I have this entry 1st of August and then 1st of September, October, November, so on and so forth. That's how you can choose intervals. You can choose daily interval, you can choose weekly intervals, and you can also choose monthly intervals. Now in the fifth argument, we have headers. Now from this argument, you can specify if you want to have headers or not. When you use stock history function by default, you get headers even with a single entry. And you can disable it using the headers argument. But there's one more option that you get with the headers argument, and that's showing the code for the company for which you are extracting the stock price and also the code for the stock exchange. You can see here, even with a single entry, I have the headers and I also have this symbol that shows the stock exchange and the symbol code for the Microsoft. And after that, we have this argument called properties. Now with the properties, you can extract stock price in different ways. Let's say if you want to extract closing stock price, you want to extract opening stock price, you want to extract high or low stock price, you can choose it with the properties. And you can also extract the volume for the traded volume for that particular date or for the entire range of the dates. And the properties argument can be used again and again. If you have 6 properties, total 6 properties from date to volume, you can use properties argument 6 times. Even you can use it multiple times if you want. Now let's start with a simple example to understand how to use stock history function. I'm going to go with the stock history function and now let's start with a simple example to understand how to use stock history function. I'm going to enter the function stock history, and in the first argument, I'm going to select the symbol that I have and then the starting date and then the ending date. And I'm gonna hit enter to close my function. And here you can see again, I have got 6 dates with the closing stock price. Now, let's say if I want data for a bigger range, let's say instead of August 2025, I want it for 2023. In that case, you can see I instantly get a table which is quite long, have almost 508 entries for the dates and closing price. Now, in the same way, when I edit my function back, I have this argument interval. And here I can choose if I want data daily for every date or weekly or monthly. If I go with monthly and close my function here, instead of having daily data, now I have monthly data starting from 1st of August 2023 all the way to August 2025. Now, when you're using this interval argument, there's one thing that you need to understand. You can see here, I get this date 1st of August 2023 and I have this closing stock price. But this is a little misunderstanding and little confusing here, because when I say closing stock price for the month of August, it should be the price which is on the 31st of August, not on the 1st of August. To verify this, to make you understand, what I'm going to do is I'm going to use this starting date and the ending date. This is August 2023, 31st August 2023. And again, I'm going to enter the stock history function. I'm going to specify the symbol and 1st of August 2023 and 31st August 2023. Now, when I hit enter, I'll get data for the entire month, day wise. And you can see here, let me just change the width. And you can see here for 31st August 2023, I have the stock price 327.76. And here is exactly the same price that I have. And here the date is 1st August, but the price is 336. That's not the closing price. It's the closing price for the 1st August, but not for the particular month. The particular month's closing price is 327. So that is something confusing, because when someone looks at it and they don't understand how this function works, they might think this is the closing price of 1st August 2023 for that particular date. Now, when I move down, because we are into August 2025 and the month is not yet complete, it shows the data for the yesterday's closing, which is also confusing again, because it's showing one for each, the first date for each month. So the best way to avoid this problem is to open your format cells. Once you get your data with stock history function, you can open your format cells using Control and 1, and then you can change the format of the dates from here. Instead of showing day, you can just go with month using M 3 times and hyphen and YY. It will remove day from the date and you will only get the name of the month and the year. So this is a very important point to understand when you're extracting data for a long date range. Now, when you're using stock history function, this is also important to identify the stock market from where you extract data. Now, take an example of Microsoft, which is listed on multiple stock exchanges, let's say in United States and Austria. Now, when I enter stock history function and specify my symbol, that is the ticker for Microsoft, and then I specify a start date, you can see I get this data for 1st of August and closing stock price for that particular date. Now, when I go to the headers argument, you can see here I have these 3 options here: no header, show header, and show instrument identifier and header. Now, when I use the third option and hit enter, I also get code for the stock exchange. That is the market identifier code. And you can see this XNAS is for United States. Now, as I said, Microsoft is also listed on Austria's stock exchange. If I want to have data from Austria, first of all, I need to have the symbol of that particular stock exchange. And then I'm going to enter a colon and the symbol of the stock. And now when I enter stock history function and specify the stock, specify the start date and hit enter, now you can see I get data from that particular stock exchange. Let me just use the headers here. And you can see this time I get data from Austria instead of United States. This is how you can specify the stock market from where you want to extract data. In case if that particular company is listed on multiple stock exchanges in different countries, even there are companies which are listed on, exchanges within the same country. In that case, you can use the market identifier code and specify to get data from that particular stock exchange. Now, you might be asked this question, what makes history function to fetch data for a particular stock from a particular stock exchange? Well, that's purely based on how Microsoft is getting data from their default data providers. To answer this with an example, let me enter the stock symbol for Vodafone, which is listed on London Stock Exchange. When I enter stock history function here and specify this symbol, the start date, and now I'm going to use the end date as well. And now when I hit enter, you can see I get data for starting from 1st of August to 8th of August. But when I specify headers, I say show instrument identifier and close function, I get this code XLOOKUP. That means the stock exchange in London. And this is by default. I have not mentioned the market identifier code here. This data is by default is getting extracted from the London Stock Exchange. Now let's use an example to understand properties. When I enter stock history function and select my stock symbol, starting date and ending date, and hit enter, you can see I get two properties here, basically the date and closing stock price. Now, when I move to the properties one argument, I have total 6 different properties to get. The first is date and close, which is by default I'm getting. But when I select the third property, that is open, and specify 2 for that, and then hit enter, you can see now I'm getting only the opening price without date and the closing price, even though date and closing price, the close price, was default in the function. This is something you need to understand if you want to have multiple properties in one way. Once you activate the third property other than date and close price, the closing price, you need to specify the property number for date, closing price, and the third one or the fourth one that you want. This way, first of all, I'll use date, and then again in the next argument, property 2, I'm going to go with open, and again with the close using 1, and for high I'm going to enter 3, for low 4, and for volume 5. These are all the 6 properties that we can have using the stock history function. Now when I hit enter, you can see I get date, opening price, closing price, high, low, and the volume for that particular date. That's how you can use the properties for stock history function. The only thing is to understand that when you activate any of the properties other than date and closing price, you need to use the property number for date and closing to get it. Apart from having this ability to extract stock price for a particular company from a particular stock exchange for a particular date, stock history function also have ability to extract the currency exchange rate. When I enter stock history function here and specify this code where I have USD and then a colon and then the code for euro and then specify my start date, it's exactly same how we extract stock price and close my function and hit enter. You can see I get this small table where I have exchange rate for USD to euro. That means I'll get 0.86 euros for 1 USD. And if I want to do it exactly opposite, I'm going to say EUR and then colon USD. And it gives me the exchange rate from euro to US. Your currency symbol needs to be in this format where you have one currency code and then colon and then the second currency code. And just like stock price, you can use different properties to get data for currencies. I'll go to properties argument and say I want date, I want opening price, I want closing price, high and low. And in currencies case, we don't have the data for the volume. I'm going to go with these 5 properties and hit enter. And here you can see I get data for all the 4 properties and along with the date column. And if you're trying to extract data for a date for which data is actually not available, in that case, you'll get a value error. And even if you skip specifying the symbol, even if I'm just, using a date where I have the data, let's say for 28th of July, I have the data. But if I somehow do not specify the symbol, I'll get the value error again. These are the few things that you need to note down. And I would also recommend you to read this page from Microsoft where they have mentioned how they are getting data from third party, and they also have listed stock exchange from where the stock history function can extract data for you.